I'm the director of the Polar Research Board and the Board on Atmospheric Sciences and Climate, which is the group hosting today's event here at the National Academies. Wanted to welcome you all to today's session. Grateful for all the time you are spending with us here today. For those of you who aren't as familiar with the National Academy of Sciences, we were founded by President Lincoln back in 1863 to provide advice for the nation. We do that through a variety of mechanisms: consensus studies, roundtables, workshops, gatherings, open sessions like the one today, to be able to bring that science to the forefront. As we looked at the issues facing society, extreme events are really permeating across the nation and the globe, and thinking about the science questions that are related to them. These really span both the population and then the various disciplines covered by the National Academies of Sciences. And we've had a number of events here at the Academies looking at different aspects of extreme events. On Earth Day, the National Academy of Medicine held a climate and health summit that is looking at a research agenda and how the healthcare system can better adapt and prepare for these extreme events. In a couple of weeks, on May 14th, the Water Science and Technology Board is holding an event on water supply systems and wildfires that looks to explore the intersection of these two events. Here today, we are the Board on Atmospheric Sciences and Climate, so looking at it through that lens as we seek to cut across the various disciplines to look at these events holistically. If we could go to the slide about the Board on Atmospheric Sciences and Climate, that would be great. What we are really here is a focus within the Academy for work on weather, atmospheric composition and chemistry, and climate. We have a variety of areas in which we look at this that are cross-cutting and are using this as the focus for our event here today. Next slide, please. I really want to thank the members of our board who came together to be part of the planning team for this event. You'll see many of them throughout the day on our various panels and then tomorrow as well. And really thank them for their insights and helping shape this into a productive, helpful event for us. We also really appreciate the National Academy staff who have helped support this effort, bringing their contributions within the topical space and then the organization for it as well. And are grateful to all of our panelists who are joining us today. You know, everybody's very busy and really appreciate the time that everyone is taking to be with us and to set the stage for this important discussion about what we can learn and how the scientific community can engage going forward. Next slide, please. A few logistic items for those of you who are here in the room. If there's an emergency to leave, you go down the hallway, take a right, and then take a left, and you'll be outside. You can visit the famous Einstein sculpture that's out there too while you need. And then next slide, please. We really encourage everyone to participate. This is an open session of the board. So we have the board here who has organized it. But at last count, I think we had about 500 people registered who are both in the room and online. And we really want to make this a dialogue and hear your questions and your insights. And so to facilitate that, we're using Slido. I promise it's fairly easy to use. If you haven't used it before, you can scan the QR code or enter this event. So please use that to ask your questions, upvote, downvote, all the things. But we really want to make this an interactive event and be able to take advantage of all the knowledge of all of our participants today. Next slide, please. So to talk a little bit more about BASC and how we are viewing this event, and the committee is the chair, Brad Coleman, who will speak to us next.
Thank you, Casey. Good afternoon. Good morning, everyone. Nice to be here today. I want to welcome you to our open session of our board meeting. As Casey mentioned, we're interested in a lot of topics across atmospheric sciences and climate. And what we know very quickly, what we've learned very quickly as we move into the session is, one, as talented and as diverse as our members are, when you look at this list of members, we need community input. We need to lead on subject matter experts. We need that diversity that you can't possibly put on one board here at the National Academies. So these open sessions are very, very important to us because they give us this opportunity to pick a topic and talk about that topic and engage and bring in those subject matter experts so that we can gather that information and package it in a way that then we can pass on to Casey and her staff, and they can pursue these as possible topics. So this is really information gathering for us, trying to get a pulse of the community and where these different things really resonate and where then we can advocate for them within the National Academies. I'm not going to read, you can see all the talented people here. So if we move on to the next slide, I do want to just take a moment to acknowledge Linda Mearns, talented geographer, climate scientist, unfortunately passed away in January. Her comments were always spot on and often very candid, if you knew Linda. And she will definitely be missed from the board and her community. So I want to now go on just a quick introduction on the session itself. Helene floods, Los Angeles fires, Phoenix heat. They're all sort of just common household terms almost now. People, many of you in the 500 plus people online, you're here because they mean something to you. Maybe you were close by or you had family impacted. But these events, significant extreme events, are critically important. And they're really the impact of the science that the BASC really focuses on, atmospheric and related sciences and climate. And we're interested in that, in the impact of these events and why there's such interest. And if we look at the next slide, this is, we've seen these, again, you see this in the evening news. These events are spread across the country and very diverse in impact. You can see across, we have drought, heat wave, flooding, hail, severe weather, tornado, tropical cyclones, wildfires, winter storms, and cold waves, solar, all these things is not there, but they're incredibly impactful to our country and across the entire United States. Yet I think for many people, it's a little bit, well, that's interesting and I'm fascinated and I feel sorry for those people, but it's not going to ever happen to me. But what we know is these events are increasing. They're increasing in frequency. We have a changing climate. They're increasing in frequency and severity. And if you look at this next slide, these are NOAA from, I forget the name, or the group from NOAA that does it, but this is a time series of these events, a number of events per year of all the $1 billion plus disasters with the CPI adjusted. And what you see is that last couple of years, about once every 12 days or so on average, we have a $1 billion disaster in the United States. So this isn't all climate change. It's exposure. It's different values and factors that come in where people are not making the right decisions or they're not getting the right information. We have cultural barriers that interfere with the way we communicate these things to the society. So more and more, and tragically, we're losing more lives than we should lose. We have more damage than we should experience. So this is why extreme events are so important to us, and why, as Casey said, the National Academies has focused a lot on severe events, extreme events. So next slide. For this particular session, this open session, which is, this afternoon and tomorrow morning, we're really looking at sort of three main areas. One is the specific characteristic dynamics of these recent extreme hazard events. You could see we could have picked any number of different events, but we chose these three. They're diverse, different regions, different kinds of physical processes. So we want to just understand better what's going on with the physical processes themselves. And then boots on the ground. Learn from those who went through it. What helped you? What was the right information to help you make that decision? What didn't you hear? What happened? What was good? Where are the successes? Where are the gaps? Where are the failures? And we want to really bring those highlights. And that's all the way from the science to the end user. Where were there wins and losses and gaps? We want to really engage, and that's why you'll see a diversity of speakers today and tomorrow, but really highlight that people who have experienced these particular events and have knowledge that we need to understand and appreciate so that we can move on and improve the sciences and all across physical sciences, behavioral sciences, so that we can bring value to the US. And to do that, we want to identify that specific knowledge that the communities need. We want to turn this review of 3 critically important events into how do we play that forward in a way that we can benefit from those insights so that we can pass on the right advice and recommendations to BASC. So we're trying to take those lessons learned and move them forward. So we're looking for needs, and we're looking at them in 3 different areas. One is just, are there gaps in the foundational sciences? Are there gaps in the physical sciences, the social and behavioral sciences that we should address? The second is, how do you take all the investment in science, all the advances in science, and get that into operations? It's not an easy task. You know, how do you take that, what we learned in the science, and all of a sudden apply it in real-time events? Very, very hard, and lots of challenges. So we're looking for places there that we can bring some attention to and focus so we can do a better job, a faster job to get that benefit in the field. And the final is opportunities to improve real-time response. What's going on, and collect those opportunities. So we move on to the agenda now. What you'll see very quickly here is that today we're going to look at 2 case studies, the Los Angeles fires and the Phoenix extreme heat. Pretty much just, go through those. Excellent speakers, discussion, should be an excellent afternoon. Tomorrow we'll come in and we'll look at Hurricane Helene in North Carolina, the flooding, what happened there, what went on. And the final session will be a wrap-up session, but this is where we're going to try through discussion. We have an excellent panel put together with 3 panelists looking at each of those events, broken down by the categories I just went over. 30 minutes of presentation with the panelists, and then as a group broad that we can bring together and identify these so that we can take that information and play it into future benefit to society through BASC. So with that introduction, I'm excited and honored to introduce our moderator for the first session, Bart Croes, board member from California Air Resources Laboratory, Air Resources Board. So it's yours, Bart.
Good day. I'm Bart Croes. I'm the retired research director at the board, and we're the agency responsible for regulating the sources of California's air pollution and greenhouse gas emissions. As we saw in the horrific images in the news last January, a buildup of vegetation, drought conditions, and high winds led to multiple fires in Los Angeles County that were extremely difficult to control and tragically led to 30 deaths and many thousands of homes and businesses destroyed. It will likely be the costliest fire in U.S. history, with initial estimates of insured losses ranging from $20 to $45 billion. Due to global warming, fire seasons are getting longer, and although there's been no discernible increase in the number of fires, they're getting more intense, larger, and causing more direct damage. There's also the issue of impacts from toxic smoke and ash on otherwise undamaged homes. Wildfires also increase downwind air pollution levels and impact human health, with an estimate that it's affected 3/4 of states in the continental U.S., eroding about 25% of our previous progress on PM 2.5 particle levels since 2016, and more than a 50% reduction of previous progress in many Western states. This causes thousands of premature deaths and other health impacts each year. As our populations have expanded, more and more housing has been located next to forests, grasslands, and other wildland areas. In 2020, it was estimated that 33% of U.S. homes are in these areas. 4.8 million U.S. homes were identified at high or extreme risk of wildfire, with more than 2 million homes in California alone. As a consequence, California has invested billions of dollars in building resiliency in its firefighting capabilities. We have 4 exceptional speakers today that have worked on the causes, preparations, immediate and the immediate response of the LA County fires, as well as working on rebuilding to ensure future resilience and the role of climate change and what we should expect in terms of future vulnerability. We will also hear from them how the atmospheric science community is helping these efforts and the recommendations on what more is needed. Our first panelist is Dr. Alan Tallhelm, the Assistant Deputy Director of Climate and Energy at the California Department of Forestry and Fire Protection, or CAL FIRE for short. Alan has an academic background in ecology, worked on air quality at the US EPA, did wildfire, forestry, air quality, and climate work at the California Air Resources Board, and has been heavily involved in California's efforts to comprehensively address its wildfire crisis through the governor's Wildfire and Forest Resilience Task Force. Alan?
Great, thank you for having me. Let me, are you going to share my presentation? I don't have sharing turned on. It says I need to send a request.
I think the staff is taking care of that, Alan.
Okay.
You should be able to share now.
Okay, thank you. Let me figure this out here. Let's show this. All right, can you all see that?
Not yet.
Not yet. All right.
Not yet.
Oh, geez. Let's try that.
It's coming up now. You see the full PowerPoint.
You're seeing the full PowerPoint. All right, that's not what I want to see. Apologies for the technical difficulties here. How about now? You see just the presentation view?
That's it.
Yes.
All right, great. Okay, yes, so I'm from as Bart said, I'm from CAL FIRE, and I'm the Assistant Deputy Director for Climate and Energy. I'm going to, start by giving you a little bit of context for the LA wildfires, and then talk about some of the LA fires, and also some of the other extreme wildfires that we've seen in California. This is not a new phenomenon for us in California. Again, talk about some of the policy responses that we've seen in almost real time, these climate adaptation responses, and then some of the atmospheric science needs that we have as well. Let's see. Advance these slides here. All right, so the LA wildfires that happened in early January were a confluence of 3 different weather events. First were Santa Ana winds. These are strong seasonal winds that are coming down mountain from the interior of California, so they're very dry winds. They're not necessarily very hot winds, but they're very dry wind, very low relative humidity in these winds that blow from the interior out to the coast, typically in fall and into winter. And the National Weather Service described this particular event as a high-speed river of air with mountain gusts of 70 to 90 miles per hour. So hurricane force winds. A second confluence of the second factor that was happening here was there had not been any meaningful winter precipitation. So California has a Mediterranean climate where we get nearly all of our precipitation in the winter months. From late fall through spring, and there had not really been any meaningful precipitation wetting Southern California prior to this event for this winter. And then a third factor is that the 2 previous winters had been very wet. So for downtown Los Angeles, the average annual precipitation is around 15 inches per year. The 2 previous winters had gotten more than 25 inches of precipitation. So this was great. The reservoirs were full, but it also caused a lot of vegetation growth, a lot of grasses, a lot of shrubs, a lot of fine fuels that are really good at carrying wildfires. So when these fires ignited, we had very dry fuels, we had an abundant amount of fuels, and we had very strong winds pushing them into urban environments very quickly. Some statistics. So the 2 main fires were the Palisades fire and the Eaton fires. There were 30 fatalities. There were more than 16,000 structures destroyed. And I want to really point out that this was an urban conflagration more than it was a traditional wildfire. And what I mean by an urban conflagration was uh, these fires were spreading from structure to structure more than they were spreading from vegetation to vegetation. You know, if you go back and look at some of the satellite imagery, you will see green trees and other vegetation next to homes that were destroyed. So it wasn't necessarily the vegetation that was carrying these fires, it was the structures themselves that were providing the fuel as these fires spread into urban environments. We knew these winds events were coming. There were assets pre-positioned to the fires. There were more than 110 engines moved into position in Southern California and associated personnel. But at peak response, there were more than 16,000 personnel there, around 1,500 engines, and more than 80 aircraft in place in California. And I want to, point out in this photo, you can see very clearly all of the embers blowing very hard. And so that you can imagine just the homes and the other structures just being showered with embers, and that being, the root cause of a lot of ignition, and that allows the fire to jump great distances more than and just traveling through direct heat structure to structure. And it also makes it very challenging to fight. And it also makes it so that when the winds are at the peak, you can't really deploy any firefighting aircraft. California and Los Angeles County have excellent aircraft fleets, but when you drop water or retardant into winds this strong, it disperses so much that it's not really effective. You can't safely fly aircraft under these conditions, and so that hampers significantly firefighting efforts under these conditions. So LA was terrible, but California, we have a history of terrible wildfires. A recent past example of this was the 2020 fire siege. So this is cover art from a report that CAL FIRE wrote on the 2020 fire season that we experienced. So this was another extreme event, although an entirely different extreme event and actually a series of extreme events. The summer of 2020 was very hot. It was very dry. But then we had an unusual weather event of remnants of a tropical storm moved up into Northern California, which happens very infrequently. And there were, I believe, over 10,000 lightning strikes, and that ignited hundreds of different wildfires across the state, which really overwhelmed the resources that we had for firefighters. And so these fires got very large. There were already existing fires happening throughout the state. There had already been a lot of wildfire activity, so resources for fighting these fires were very limited. And so there were a lot of acres that burned in these fires that were caused by not only lightning storms, but subsequent other events as well. So you can see on this map, all of the red areas are areas that burned in 2020. So there were 31 fatalities total from these fires. There were more than 9,000 structures that burned here, and in total burned more than 4.2 million acres across the state, which is a dramatic increase. Last year, which was also a high fire year, we had a bit more than 1 million acres that burned in California. Just putting that 4.2 in context. So it's really far off the charts from what we had seen in California. And of course, another extreme event that we had was the Camp Fire in 2018 that burned the town of Paradise and surrounding communities. There were 85 fatalities in this fire, more than 18,000 structures destroyed, and it burned 153,000 acres. And this was in Northern California, to the north of Sacramento, in the Sierra Nevada foothills. But in some ways, the weather conditions were similar to what was experienced in Los Angeles. So the winter of 2016, 2017 had been very wet, created a lot of fuels. The winter that immediately preceded this fire, the 17-18 fire, had been very dry, and there'd been very little rain in the summer and in the fall prior to this fire. And then there was a strong wind event and an ignition from a Pacific Gas and an electric power line that started the fire, and the fire spread very rapidly through this town that had limited ingress egress routes, and led to very many fatalities and structures destroyed. And so here's a list of the 20 largest wildfires in recorded California history. So it goes back to around 1930. And I don't want you to read this whole slide here. There's a lot of text, but I want you to focus on that second column, the date column. If you can read it, you'll notice that all of the fires here, except one, have occurred since 2003. All of the top 5 have occurred since 2018. All of the top 9 have occurred since 2017. And so the amount of large wildfire activity that we're experiencing in California has gone up dramatically in recent decades. And climate change is certainly one of the factors that we can attribute to that increase. As Bart mentioned, there are tremendous air quality impacts from this in California. So these are some images from 2020. I think the image of San Francisco looking orange skies at midday is something that it's certainly stuck in the brain of many Californians. I think it was a very striking image around the country back in 2020. These satellite images also shows the spatial extent of that smoke in 2020 as we were experiencing these widespread wildfires. All the dots on those maps are active wildfires. And as someone who was in California for this event, and also there have been tremendous air quality impacts from other fires in California, sort of similar to this in 2017 when the North San Francisco Bay wine country burned, when Napa and Sonoma burned, and then 2018 when the Camp Fire burned. We get these blankets of smoke. 2020 was particularly bad because it was also the COVID pandemic. So you couldn't go to public places indoors. You couldn't go outdoors because it was too smoky. The AQI our air quality index was 200 or 300. And so you were stuck inside for, weeks at a time. And we don't really have, I don't think, very good information, good science on what the public health effects of this are. I think we have a good understanding of chronic exposure to PM 2.5, from factories and vehicles and things like this. But as far as these repeated, prolonged, sort of acute smoke experiences that we've had in California and in other places through the West, it's really unknown what the longer term consequences of this are going to be. Another component of this is that when the built environment burns, the stuff that is in the built environment is also going up into the atmosphere. And this is another place where we have science needs in atmospheric science. So this is some lead concentrations in PM 2.5 in 2018 during the course of the whole year. And you can see a tremendous spike in some metro areas during the Camp Fire when the town of Paradise burned. We don't necessarily understand the health consequences of this. We don't necessarily understand all the emissions that are being produced when all these structures burns and where all those emissions are going and what the dynamics of all those things are. So this is definitely another clear need that we have as well. There are also definite water quality impacts from these extreme wildfire events. When a town burns and that municipal water system is affected, there can be very difficult to resolve effects on water quality where those homes are burning, those commercial buildings are burning. That is putting pollutants into the municipal water system, things like benzene. They're going into the water system, and it's very, very difficult to remedy those issues. The water infrastructure sort of upstream of municipalities can also be impacted in terms of our conveyance systems. Burning the watersheds also produces a lot of silt, makes them very vulnerable to runoff, which can cause a lot of sediment impoundment behind dams. And there can also be nutrient impacts where the water quality changes can lead to algal blooms and other things like that are very difficult to deal with as well. How has California responded? Well, one way we have responded is providing more firefighting resources. So I work for CAL FIRE. The number of CAL FIRE employees has more than doubled in the last decade. There are approximately 12,000 of us right now, with plans to grow another 2,500 over the next several years. So putting more firefighters on the ground is certainly one of the responses here. We've also updated and expanded our aircraft fleet. So CAL FIRE has approximately 70 firefighting aircraft that we use, including night flying Black Hawk helicopters, which is that's a new addition to our fleet. And we needed night flying helicopters because we are seeing more overnight fire activity because of changes in atmospheric conditions with climate change. So more active fire activity. We needed more helicopters that were capable of dropping water at night. We've added these new C-130s that are a transfer from the U.S. military that are being integrated into CAL FIRE's fleet. And we also have added new technology that have allowed us to do a better job of both firefighting and also communicating to the public about these risks and providing them opportunities to respond themselves by evacuating and preparing themselves as needed. So one example of that is Alert California. Alert California is a camera network throughout the state. There are more than 1,100 of these cameras that are located on towers and ridge tops throughout the state. This is a partnership between the University of California, San Diego, and CAL FIRE. And so in addition to all these cameras being out there around the state, these images are processed with artificial intelligence from a partner called Digital Path. And what these cameras are out there doing is detecting wildfires and detecting them as fast as possible so that we can assign resources to those fires, send a helicopter out there, send fire engines out there to try to extinguish these fires before they get large and difficult to control. And these cameras have been very successful. A number of times, these cameras are able to identify fires before they are reported in via 911 or other channels and allow us to really attack these fires very aggressively before they get out of control. Another example of technology is our website. So this is a screenshot from yesterday evening of our website. We zoomed in on a portion of the state, and I'm going to point out a few things here. First, I've clicked on this small fire, the Pioneer Fire. Yes, it's already fire season again in California. Even in early May, we've had, in addition, we had fires in January. I think February we had a relatively low month, and then we had a couple thousand-acre fires in March and April already as well. So clicked on this fire, it gives you some stats on this. Across the board are to date for the year statistics cumulatively. The big gray blotch on this screen is the Park Fire from last year, which was one of the top 5 largest fires. That was over 400,000 acres that burned on there. You can see a little helicopter on the screen right here. So there's real-time information on our aircraft and where they are across the state. If I had gone to click view details of the Pioneer Fire, it would show us the current evacuations on a map. It would also show us, provide us links to the Alert California wildfire cameras, so you could have a real-time view of the wildfire activity of this particular fire and the different cameras that had a view of that fire at the same time. And also show you the number of specific resources that we have assigned to that fire, number of firefighters, aircraft, et cetera, et cetera.
Just add 12 minutes.
Okay,
So-
great. Well, I'm getting toward the end. So firefighting resources is great, but we also realize that we need to be more proactive in protecting our communities and creating more resilient landscapes to fire. So one element of that is the creation of this Wildfire and Forest Resilience Task Force, which is an interagency body. Much of California is federally owned for the Forest Service, Park Service, Department of Defense, Bureau of Land Management, et cetera. So this task force brings together state leaders, federal leaders, as well as local governments and tribes together to create a comprehensive approach to making California more prepared for wildfire, moving beyond just sort of land management and firefighting to think about the way that we are developing our communities, the data and science tools that we have, bringing in expertise from the UC system and from the California state system, and also the national labs that we have here in California. We've also established some high-level goals in California, such as treating at least 1 million acres per year for wildfire resilience treatments by 2025, and adding 400,000 acres of beneficial fire. So prescribed fire, cultural fire applied by Native American tribes, and also wildfire managed for resource benefit. This is another atmospheric science need that we have, is understanding how to manage this smoke, how to create this smoke and not put it in communities, how to mitigate the health impacts of this smoke. This is a very pressing research need as we scale up our use of good fire in California. And then I want to also touch on what we're doing around communities. We have updated building codes, Chapter 7A, going back to 2008. If we know that homes that are built to these improved building standards have a much greater survivability of wildfire. We also have grants for home hardening. So home hardening is doing things like replacing your roof or putting screens on your attic vents to make it less vulnerable to fire. We have a grant program for that. And then we also have improving defensible space standards. So defensible space is removing the fuels from around your home in various zones, including zone 0, which is immediately around your home where you're supposed to have zero combustible material. And then we also do defensible space inspections throughout the communities where CAL FIRE inspects 300,000 homes per year. And with that is the end. Bart, if I have time for questions, we can do it now, or otherwise we can move on.
Thank you, Alan. We're going to hold questions until we hear all 4 presentations. I think it'll just be more efficient that way. Our next panelist is Roy Wright. He's the President and Chief Executive Officer of the Insurance Institute for Building and Home Safety. Roy's a property insurance and disaster resiliency expert, and prior to leading the Institute in 2018, he served at FEMA, the Federal Emergency Management Agency, as the Chief Executive of the National Flood Insurance Program, led the agency's Federal Insurance Mitigation Administration, and directed resilience programs addressing earthquake, fire, flood, and wind risks. He's also a California native, and his insurance institute was on the ground at the fire. Roy?
Thanks so much. Good to be with you all. I think the technology is all in place. IBHS does the physical science specifically on when Mother Nature and these hazards come into the built environment. So we do work across wind, rain, hail, flood, and wildfire. Today, I want to talk about the wildfire element because in our instance, yes, we have a lab where we can do the only full-scale ember testing, showering ember storms on structures, but that is always bridged then from a post-event perspective on being on the ground so that what goes on in the lab meets those pieces. Particularly for those that have tuned in, I want to take a couple elements related to wildfire and lay them just as foundations, because all too often the public has this image that there's a wall of flame that comes towards buildings. So it's kind of this movie-esque version that is here, when in fact it is embers that drive preponderance of those ignitions when they play. Yes, embers can come from organic material like trees and bushes, but also can play from structures. So you watch this piece from an ignition source, whatever that might be, whether that is human driven, that may happen from a utility, it may happen from lightning. Then you have the extreme fire behavior that brings you in and ultimately pushes you through to the point by which we're dealing with structural pieces in a suburban conflagration response. In terms of our work, we're mindful of structures that might burn homes or cabins that are in the wooded areas. Our research primarily, though, focuses on conflagration, that point by which we have those cataclysmic, uncontrollable structure to structure spread. There's no scientific threshold on this conflagration, but most commonly you're going to be in the hundreds and likely thousands of structures that have been impacted when we use this term conflagration. When we deal with structural conflagration from wildfire, there are always 3 pieces that need to be true. You have to have humans, you have to have drought, and you have to have wind. Universally, as we look at these conflagrations that have played out over the last 10 years in the United States, you will always see humans, whether that's from an instigation perspective or how humans need to evacuate or the structures that they live in. Droughts, even oftentimes these can be flash droughts, although the longer term ones would affect this as well. And then the winds that have been mentioned, they'll come up a couple more times here, sometimes called Santa Ana winds in Southern California, Diablo winds in Northern California. But if you're to go to the front of the Rocky Mountains, they're going to call them Chinooks. They are the same kind of dry, hot, downflowing winds that played out in Lahaina as well. As was mentioned, I spent a lot of time in FEMA looking across hazards. And when we do work to help those adapt or prepare or mitigate for flood or wind or even earthquake, you can change your structure. And if you do that, you will have taken necessary action. But when it comes to wildfire, it is a two-sided equation that both have to be addressed. There is work to be done at the parcel or home level and work at the neighborhood or community level. You can do everything perfectly, and the next door neighbor who has not taken action will be the source of your failure. This is not true on flood. This is not true on wind, but there's a communal piece with wildfire that is truly unique. So let's go to Los Angeles, the pieces that were there. We have a flash drought. We have the gusts that are playing out in this space. The sustained winds, I know it was mentioned earlier, those gusts can wind as high as 90 miles an hour in the Altadena side of the equation. But really the sustained winds between 40 to 60 miles an hour really became so much of the difficulty there with very, very low humidity. So, in the very limited time, I'm going to try to give you the Cliff Notes version of some essentials that are here. So for conflagration, there are three factors: structure density, connective fuels, and building materials. When we do this work at the lab as well as in the field, these are the pieces that we continue to see. I'm going to give you just quick snapshots at what those look like. The building material pieces that are there, whether we're looking at the windows, and you can see there how they have cracked because of heat that is nearby. You look at the various kinds of external material, quite a bit of stucco in Southern California. But you'll also see that the way that embers accumulate, they create a small vortex of about 5 feet and rotate when they come up next to structures, making the bottom 6 inches of the structure probably even more vulnerable because it's a place where things can be trapped. Even when you have dual pane windows, which are called for in these higher fire prone areas, we often see the vinyl around that holds the window in give, at which point the upgraded windows simply just fall right out in these elements. We talk about connective fuels. I'll start on the bottom left here. Fences are often like the first thing we look at. In a perfect world, we wouldn't have wooden fences from this risk, but it's really the 5 feet closest to the house. It's the gate that touches the house that becomes that connective fuel. It can be the kinds of things that are in that place where even if that had been a metal, you would have given yourself a fighting chance. Trash cans. The flammable trash cans were often the point of entry to fire on structures. Those plastic cans, sometimes we would show up and actually see them entirely melt down to just be 1 centimeter thick and about a half a meter wide. And you would just see the wine bottles would be the only thing that had survived those pieces. Those torch up into the eaves and catch the house on fire. Hot tubs. You might think because a hot tub is full of water that it's actually helpful. It is not. All of that plastic around this and those standalone hot tubs that are very, very common in California and across the West are highly flammable. And you can see the kind of impact they can then have. This case here on the right, there was clearly firefighter intervention that took place to save that structure. I was talking about how those elements play. This is from our lab where you can see that last 5 feet by being a metal fence actually protected this structure from igniting. Everything around it, that 5 feet is non-combustible, as Alan mentioned. But even with fully inflamed fire that close, you can see those pieces play. And then we talk about structure density. This is a view of some of the testing we do at our lab where we engulf full-scale structures against targets. We have an ability to control the wind speeds in these spaces. Embers bring the fire onto the block. When the structures are close together, oftentimes we see them just 10 feet apart. We start seeing structure to structure fire. At that point, it's a combination of flame, but really the radiant heat that is driving those dominoes farther down the road. Alan mentioned this. We get embers coming from some wooded areas, and they can land, find structures and cause that first ignition. Once that structure is ignited, it is throwing off embers. But instead of organic material, we start seeing things often the size of your hand. Imagine some motherboard out of a TV. Imagine the hoses from dishwashers and other that are inflamed and flying sometimes a half-mile down the road. It is not uncommon to see embers propelled 1 mile away in these instances. Except the structures are already there. I think one of the hardest things in terms of how do we adapt is when these elements are already in place. The structure to structure, though, is only going to go to the end of the block. At the end of the block, you've got a 50 to 80 foot wide fire break. How did the fire get across the street? Embers. And oftentimes there's a series of hopscotching. So we'll see these pictures after the event, and we'll see entire blocks just gone. I think our first thing is to think, oh, it just kept moving like dominoes all the way down the hill. But in fact, the fire likely had a series of overlapping pieces by which it was not sequential as much as a far more chaotic movement that is there. So what do we do about it? During the Q&A, I'm happy to go into more of the details. We embedded with the CAL FIRE damage assessment teams after the event to do this work. But let's talk briefly about the kind of solutions, because the science is clear enough about what to do at the parcel level and what to do at the home level. A key difference, again, from wind or flood from fire. On wind or flood, you can work from a menu and incrementally make progress. And each individual thing you do makes you a bit more resilient. In the case of wildfire, that is not true. And so there is a suite of actions that are an integrated system that's shown across the bottom here that have to be done collectively in order to mitigate against embers. So roofs, the good news is most roofs in California are already Class A, but there are still some wood shake shingles that are out there. The building features, Alan referenced the ember resistant vents, as well as what happens underneath decks. And finally, that 5 feet closest to the structure. The science is really, really clear on this. Nothing flammable. The embers will find the weakest link every single time. Similarly, we've done some work at the neighborhood scale, looking at, first of all, how embers attack, and then secondly, what you do from a connective fuels of the structure to structure pieces that are there. I referenced the Wildfire Prepared Neighborhood Technical Standard that is posted. Happy to ask more questions about that. In San Diego County, down in Escondido, the first track-built community to meet that standard was introduced earlier this spring. KB Home, one of the national home builders, committed to take this entire development of 64 homes and build them to that higher standard. This takes what was referenced earlier, the Part 7 of the California Building Code, and takes it just a bit higher so that when embers come and land in the community, the structures are least likely to ignite, and if they do, the connective fuels have been minimized to really shrink or reduce the paths of destruction. So much I can show you on these pieces, but I want to keep coming back to, if we're going to reduce the structure ignitions and we're going to reduce the likelihood of conflagration, we have to make a change. I showed the pieces for new construction. Frankly, the pathways for new construction are simple and clear, and they're almost cost neutral. When it comes to retrofitting existing homes and neighborhoods, this is really, really hard to get a whole set of property owners to take these actions, knowing that your perfection is negated by your neighbor's lack of action. It is clearly a place that insurance companies have focused as they've seen this risk grow. That's a pricing signal that meets folks. But fundamentally, the kind of atmospheric realities, the climate changes that are exacerbating this, then laying on top of these communities that have been built out, put us in these positions. The Palisades of California had been identified as an area of high wildfire concern. Still makes that a really difficult day when it plays out. Altadena had not. A very small ribbon of structures were of concern right up against the wildland. And yet more than 10,000 structures are lost in that space where that urban conflagration moves so quickly in this world. We know the right things to narrow these paths. The social science, the behavioral economics by which we can get people to choose to take this is much harder than figuring out the physical science in this space. So Bart, with that, I'll turn it to my next colleague.
Thank you, Roy. Our next panelist is Dr. Joost de Gal. He's a professor in the chemistry department and a fellow of the Cooperative Institute for Research and Environmental Sciences, or CERES, at the University of Colorado in Boulder. His research is focused on air quality, and among other expertise, his group specializes in measurements of organic trace gases in air using mass spectrometry, and as well as wildfire emissions, including those from the Marshall Fire in Boulder. Joost?
Yeah, thank you, Bart. So I'm going to present on a different urban fire, the Marshall Fire, which was more than 3 years ago, but had a very similar story as the LA fires. It happened in the middle of winter, December 30, and the preceding year had a wet spring, so grasses could grow abundantly, and a very dry fall, so all of those grasses dried out and provide a perfect fire starter. So the fire is now 3 years ago, more than 3 years ago, and that has given us enough time to write some papers about the environmental impacts. This is not just my work. I had a lot of collaborators contribute to these slides, so I'm presenting our collective work. So this map shows the perimeter of the Marshall Fire. The burned area was something like 24 square kilometers. I am currently in Boulder, Colorado. This is US 36, the main highway into Boulder from Denver. And this is really the foothills of the Rocky Mountains, densely forested. This is where we always suspected wildfires would come from. But in fact, on this day, there was a small grass fire that erupted in the town of Marshall. And then due to these really, really strong winds, over 100 miles per hour, this small grass fire grew out of control and burned into the cities of Superior and Louisville. So these photos are sadly now very common. The Marshall Fire burned over 1,000 structures and 2 lives were lost. Of course, with wildfires, as atmospheric scientists, we've always worried and considered the impacts of smoke, and those were certainly significant. Here are some of the purple air data from the area. A lot of sensors were destroyed during the fire, or they went offline because of power failures, etc. But there were some that recorded data, and those are shown here with PM 2.5 readings over 100 micrograms per meter cube, so certainly strong impacts. But as the winds died down and the firefighters got the situation under control, the smoke impacts disappeared within a few days. And something that was much more surprising to me was the impact of the post-fire situation. So here are some photos taken inside a home that was unburned, but on the burned perimeters. And you can see the heavy impacts of the smoke. So this was a really modern home built just a few years ago. And despite having good windows, good doors, good seals and everything, the smoke definitely got inside, as you can see. There's ash and soot right behind the front door, on the top of window frames, on windowsills, etc. And also these homes smelled like campfires, and that got people really worried in combination with the visible impacts. So a lot of people did not return for weeks, if not months. And there were just a lot of questions about what they were exposed to. Were there any toxics in these materials? Questions like, my neighbor has an electric vehicle, it's completely gone. Are all of those metals in my home now? They caused a lot of concern among people. And also people wanted to know, what can we do ourselves to clean up our homes? So in response to those community concerns, what did we do? Well, the first thing is we looked at the scientific literature on this topic, and we put all of what we found together in this website. And still to this date is the most searched, it's the most visited website in our research institute. We also updated this site after the LA fires with the most up-to-date information. But really what we found in reading the literature is that there's very little known about these impacts. And that made us go out on a very improvised study. And so this photo is not of one of our chemical laboratories. It is in fact the living room of one of the homes in Superior. And we equipped this this home with a number of instruments. So this is a very fancy mass spectrometer for measuring the gases in the air that you can smell. This is a smaller version of that same instrument that will make a recurrence in the next slide. This is instrumentation to measure the particulates in the air that have a strong impact on health. And then we had a number of lower cost sensors that were all in this home on this particular day, but then were distributed to a dozen or so other homes afterwards, so we could also get a wider view of the impact. We also measured outside. We put these small mass spectrometers on wheels, and with a big battery pack, we could operate it for about 2 hours, and we wheeled it through the area. And we could sniff all kinds of burnt materials. Like here is a totally burned out hybrid vehicle with a lot of plastic parts here on top of the soil. And we also put this small mass spectrometer in the back of a vehicle and surveyed 15 more homes in the area and also outside of the area. We collected soil samples. This was done by some colleagues of mine, Thomas Borsch, Eve Hinckley, and Noah Fearer. They collected soil samples inside the burn area and also outside the burn area. And there is a creek that runs through the area, the Coal Creek, where my colleagues Julie Korek and Preston Mansfeld collected samples for several months after the fire. So what did we find from all these studies? So the first thing I'm going to look at is the chemical composition of the indoor ash and soot that we collected. So We collected a number of samples inside smoke impacted homes. We collected some samples in control homes not impacted by the fire. And then we also looked at the composition of Colorado soils as reported by the US Geological Survey. And so what you can see from this graph here is that the concentration of some more common metals that are present in minerals were not particularly high in these smoke impacted homes. But then the inset shows you the heavy metals, things like lead, arsenic. And here you can see that, that there is a small enhancement of lead in the ash samples collected in smoke impacted homes. The enhancement is not large, but it is significant and something to look into further. In LA, a lot of work like this has been done and is ongoing, in fact, and there is a lot of new research coming from that area that I've seen that's going to provide a lot more detail than we did in this paper. So this is all ash on the floor, on windowsills, etc. Does it get airborne? So our particle measurements inside these homes showed that the indoor PM2.5 and indoor PM10 were actually pretty low, except when people or companies started to clean the homes. So this time series shows the PM10, the airborne PM10, and on 2 days there was cleaning in this house, in this case by a professional crew, and you can see some really, really high values, over 100 micrograms per meter cubed. So that points to the need to protect yourself as you're cleaning a home. Colleen Reed and her colleagues led a very extensive survey effort after the Marshall Fire. And some of the questions were related to indoor air quality. So on the left, you see the responses to the question, did your home smell different after the fire? And most people say yes. And then on the right, they're asked, what did your home smell like after the fire? And most people said it smells like a campfire, and some people even said it smells like a chemical fire. People were also asked about health effects, and they reported a higher frequency of headaches and also a strange taste in their mouth when they were closer to the fire perimeter and when they reported impacts on their air quality, their indoor air quality. So our chemical instruments inside these homes indeed detected higher VOCs indoors. So VOCs are volatile organic compounds. One of them is benzene. It was mentioned before in this talk. It's carcinogenic, air toxic, and I'm showing this compound out of hundreds others that we measured. And so the time series shows the days since the Marshall Fire. Note that we got in about 10 days after the fire, and we kept measuring for about 25 days. Initially, the indoor concentrations were quite elevated over the outdoor concentrations. Then the indoor concentrations gradually but surely decreased to a point that is more normal for indoor air. These decreases took much longer than we had expected. We had expected these impacts to stay maybe for hours or days, but in fact, they took weeks. And that's something that we still don't quite understand. So a lot of people asked us, how can we protect ourselves? And so to address that concern, we built this do-it-yourself air cleaner that consists of a box fan and 4 pleated air filters, also colloquially known as the Corsi Rosenthal boxes. But in this case, the filters that we used had activated carbon. And these filters proved to be very effective at removing indoor VOCs. So The graph on the right shows that before we turn on the filters, the signal for, in this case, benzene was much higher than the outdoor signal. But then when we turn on the air cleaner, the indoor benzene went away to a level that's similar to what we have outside. Unfortunately, the effect is not doesn't last. When we turn the filter off, the indoor concentration bounces back up. So that points to the fact that there are large reservoirs of these species inside homes. You can knock down the air concentration temporarily, but you didn't get rid of the source of the compounds. And then finally, my colleagues also collected a lot of soil samples inside the burned area and outside of the burned area. And this graph here compares the measurements for several metals: zinc, lead, copper, nickel, chromium, and arsenic, inside and outside of the burned area. And as you can see, there are some enhancements like zinc in the left plot. But overall, the enhancements inside the burn area were not large. So that is somewhat reassuring. There was a lot of concern about this. These fires start in high winds, and the high winds are likely to come back at some point after the fire. And if any of the debris and ash outdoors can get airborne again, it would provide a mechanism for breathing in these toxics. So while this is good news, I should note that in LA, similar work has also been done and has shown somewhat larger enhancements of lead. And one thing to note here is that the homes that burned here in Louisville and Superior were newer than the homes that burned in Altadena. So in older homes, you have maybe lead-based paints, you have lead used in windows, and perhaps that led to higher lead releases to the environment than what we saw here in Colorado. So that brings me to my last slide. At a very high level, these post-fire smoke impacts are really a new issue for us as environmental chemists, as atmospheric scientists, to consider for the release of toxics into the environment. A lot is unknown about the toxics that you get when you burn man-made fuels. We've done some work on it since the Marshall Fire, and it shows that when you burn things like plastics, carpet, etc., you do get on a per fuel basis more toxics into the environment than when you burn wood. There's also a research need on the cleaning of smoke impacted homes. Some of the things we saw after the Marshall Fire were common sense and should be continued, but we also saw some things that do not make a lot of sense, and that should be investigated further. So with that, I'd like to stop. Thank you for giving me the opportunity to talk here. Acknowledge all of the homeowners and residents who gave us access to their homes generously, I should say, and also the funding sources that we managed to get at very short notice, as you can imagine. So thanks.
Thank you, Joost. Our final panelist is Dr. Leroy Westerling of the University of California at Merced. He's chair of the University of California Disaster Resilience Network, chair and a professor of management of complex systems, and director of management of innovation, sustainability, and technology. Leroy's research interests include applied climatology and seasonal forecasting for wildfire management, climate change impacts on wildfire and related aspects of mountain hydrology, and paleo reconstructions of climate wildfire interactions. Leroy?
Hey, it's a pleasure to be here. Let me just get this up on screen. Thanks. Yeah, so let's talk about the LA fires in the context of recent trends in climate. and their impact on fire, particularly in California. Temperatures rising are a really important part of this, but it's not the whole story. So increased warming means increased evaporation. And that has been really important for fire throughout the Western United States, but not necessarily where fires that impact the most people in California are, at least not to the same extent as forest fires. So we saw impacts of warming temperatures, particularly earlier in mountain forest areas around the Western United States. But our ability to sort of detect statistically significant impacts of climate changes on fires at lower elevations in warmer, drier locations, away from forests primarily, lagged by at least a decade. Part of the story is that on the one hand, temperatures are increasing, and that's increasing evapotranspiration. But the changes that have been observed and that are projected for average precipitation in places like California are quite modest, and very small compared to the background interannual variability that we've observed in the past, sort of pre-climate change. And that means that there's not enough additional moisture coming in to counteract the evapotranspiration and its impacts on drying the landscape, in particular the fuels that are going to drive a lot of these fires. And so we've seen in the recent past decreases in specific humidity, and that is a big part of what has driven initially increases in large fires in forested areas of the Western US. But when you think about California, most people live at lower elevations, and it's locations where it's quite dry during the Mediterranean summer anyway. So when you think about the effects of changes in average humidity over time, decreasing, say, it's going to be pretty marginal for a lot of these locations. However, warming also has meant increased variability. Now, climate change actually affects the variability of precipitation in a bunch of different ways, but one of the things that I focus on in particular has been sort of changes in weather patterns that give you slower moving systems that set up longer over larger areas and can give you more extremes and more variability from year to year. And those have been appearing to be very important for this story about increased large fires in California in proximity to developed areas in particular. So just to summarize, right? So this in the first section, increased temperatures means more evaporation. More evaporation and not much change in average precipitation means more flammable fuels for longer. And then increased precipitation variability, turns out, can dramatically affect the length of the fire season. If you lose those significant precipitation events in the fall or the winter, early winter in particular, that would have wet the fuels enough that maybe you get a fire start, but it doesn't spread and become a large fire. And it also contributes to the likelihood of you getting these sort of what the media was referring to after the LA fires as whiplash, right? So a wet season or two followed by a very dry season. And then one area that's sort of open question, but it seems reasonable, right? If you have these weather systems setting up and persisting longer and moving more slowly, can you get wind events, extreme wind events that maybe last a bit longer? So looking at fires in California. So first of all, people have said, hey, there's not much significant increase or change in the number of fires. But you have to remember that 95% more or less of ignitions are very small. and don't require a lot of effort to put out or even go out on their own and don't do a lot of damage. So when you think about the fires that become what I think of as or call management fires, the fires that get an incident commander either from a state agency like CAL FIRE or from the one of the federal land management agencies, those are typically fires over 1,000 acres in size. And that's just an arbitrary cutoff. But when you start looking at fires above that size, you start to see increases in the number of fires and in the area burned in them that's quite dramatic over time. And this is showing the annual area burned in California in fires over that threshold size. If you dissect it a bit and think about the time of year, so the green bars are showing the average annual burned area 1986 through 2000 from the recent, satellite-based fire record. And then the orange bars are showing the average for 2001 through 2020. So there's first off, there's an increase across the board in area burned, but the percentage increase is really most dramatic in the winter, right? So the late fall and winter in particular. And a big part of that story is really the loss of that fall or winter precipitation in specific years. If you think about how precipitation works in California, it's basically 5, 6 big storm events can account for most of the precipitation in a season. If it gets more variable, you're more likely to lose a storm in the shoulder season, so in the fall rather than the peak of the rainy season. Just losing one of the or two of those big storms in a row can really extend the fire season later in the year when you're more likely to get an extended wind event or an extreme wind event, as other speakers have discussed. And then in the red bar there is showing the scale of the area burned based on the satellite record for the January fires in Los Angeles. So it's pretty significant compared to the average for that time of year in California over the last 4 decades. And when we look at is Zoom blocking your view or is it just my on my computer, Bart?
It looks normal to me, Leroy.
Okay, great. That's cool. So if you look to the far right there, each of those red bars is showing the area burned in individual fires that burned in January 2025. And there were 5 large fires there. And that compares to 8 total over the preceding 40 years. So this was a very significant event. And if we see more fire in the next decade and a half or so, then we would be continuing to see that trend towards more and more fire later and later in the season. In this particular event, it was actually a very rare event. If you look at the daily climate record over the last 40 plus years. So a dot of any size is showing you the daily minimum relative humidity versus daily average wind speed. And the black dots are showing in particular the ones that occurred in the month of January. And this is for Palisades, California. And then the red dot there is showing you the conditions on the day of the greatest fire spread. So that's on the 8th. There were only about 8 days in the last 40 plus years that were that severe or worse. So, we say it's very dry fuel conditions, but actually they're not that far off of average for the location this time of year. It's well within their variability in the historic record. But what is rare is for them to be accompanied by such high winds. So typically, the high wind events have been occurring in that location when fuels were quite a bit wetter. Okay, so the combination of high winds and very low relative humidity is 99.95 percentile event. And this isn't really just a freak event, right? So I've done analyses like these for just about all the major damaging fires in the last couple of decades in California. And we see this pattern over and over again where the winds are really exceptional and the humidities are dry, but not necessarily outside the range of historical variability. So I think it's important to think about the timing of precipitation for these lower elevation sort of arid location fire events as a really important factor that needs to be explored a bit more. And in general, and specifically, are we able to see or predict better than we have done so far shifts in the wind regimes in these locations relative to the recent past? And then just talking about the whiplash again. So the previous 2 seasons were wetter in the late winter, early spring. The 1 year prior conditions were actually by just a tiny smidge the wettest in the record. And if you look at the last 15 plus years, you have the wettest and the driest extremes in the record. Statistically speaking, maybe not significant, but it is, for looking at just one individual location, but it is quite representative of what we expect to see overall as climate change progresses. And then a final note on vulnerability. We've been talking about the exposure to fire and basically the impact of climate change on that. But the other side of it, of course, is that these really damaging wildfires, 3/4 of them occur in wildland-urban interface. And that interface, this area has expanded quite a bit in the last couple of decades. And the number of housing units in that has increased pretty dramatically, so 40%. And then after adjusting for inflation, you still have a 50% increase in home values for those units in California as well. So the combination of rising property values, increased number of structures in places at risk and more areas at risk has really increased our vulnerability at the same time. So, we tend to focus a lot on hardening, but there's something to be said for thinking about the spatial arrangement of development on a landscape as well. And I'll stop there.
Okay, thank you, Leroy. So we have about, I guess, 20 minutes for questions. So Steve, do you want to do the first question, or maybe I can do that?
Sure.
Yeah, I can see him. So there's a question from Michael McCracken. I think we should direct it at Alan and Roy. So most of the structure fires is caused by embers being drawn into very dry and combustible attics. Will or has California changed its building standards to address this issue?
To extent California has already changed its building standards, so this largely applies in wildfire vulnerable areas. So if your home is not in a wildfire vulnerable area, you don't Chapter 7A does not apply to you. Although, to Roy's point, as part of his presentation, these new standards apply to new construction. They don't necessarily apply to old construction. And the challenge that we face in California is that we have many of these structures that exist that were constructed prior to the implementation of these updated building codes that we need to retrofit, and that is a very challenging problem, both from an expense perspective, like an economic impacts, and also just getting social buy-in and participation in that.
And just want to point to that, yes, to everything Alan said, but to the questioner, if you're in the area of high or very high hazard and you're doing new construction, those upgraded attic vents are the requirement in those areas.
Okay. Alan, I think there's another question for you. So given the increase in major mega wildfires in the state, what household preparation campaigns is the state doing? For example, using Ready, Set, Go alerts and educating communities and taking protective actions during wildfires.
Yeah, actually, it's a good time to be talking to you because it's I think it's Wildfire Preparedness Week right now in California. So we have a lot of public campaigns that we do throughout the state, and there are a lot of different things that we're trying to get people to do. We're certainly trying to get people to implement defensible space and home hardening. We're trying to get people to sign up for emergency alert systems so they can be notified of evacuation warnings. We are trying to give people tools to adapt to wildfire smoke. We have partners at the California Air Resources Board who are trying to give people tools. They have an app now that you can use that provides smoke modeling forecasts for you for both wildfires and prescribed fires. We'll notify you if there's a prescribed fire planned in your area that might have smoke impacts to you, so that you can prepare and do things like change your events that you're going to be doing outside, or maybe go get your asthma medications updated and things like that. So yeah, there's a lot of different things that we are trying to do and trying to get individuals to do across the state. But as Roy also mentioned, this is a community problem, and we are trying to also encourage communities to come together and ensure that all the neighbors are working together to protect their communities. Firewise communities are very popular in California. There are over 1,000 of these where communities have voluntarily come together to take wildfire preparedness steps, around defensible space and home hardening in their communities.
Okay. Roy, did you want to add anything to that?
Just that I'll be standing with Alan's boss on Wednesday in San Diego, where we'll be showing the defensible space pieces, because helping people imagine what can happen, to visualize it, is part of the answer.
Okay. And Roy, there's a question about what lessons are learned for smaller community with fewer resources and staff than LA.
I think that California is in a class unto itself when it comes to these wildfire pieces, in terms of the resources they've been deploying to it over the last decade. The fact that there are statewide building codes in these places. Clearly, when these plays out in Los Angeles, you're in second largest urban context in the country that brings resources that are there. I think that what is harder is when you get beyond California and there aren't standardized pieces. So I think about the Lahaina fire in Hawaii. I think about the communities in Oregon, Arizona, or New Mexico, where almost everything is voluntary. California is the place where you do have some mandates. Some might say they need more, but California is much farther along in that space, where the others, with just a few small community exceptions, everything that we're talking about is voluntary.
Okay. We had a couple of questions from the Basque members. So Leroy, has there been there's been research ongoing, like on the status of wind trends, peak winds, and perhaps how climate change could play a role in that?
Yeah, but before I address that, I just wanted to respond to the previous
Okay.
two, and that is just that we have really great standards in California, and they're getting updated on a regular basis. But it's still true that 10, 20, 30 years from now, most of the houses that people are living in will have been built a long time ago.
Absolutely.
So that really is the huge financial and logistical challenge for the state and everybody in it. About the winds, so the handful of studies that I'm familiar with have focused on Santa Ana winds in particular. And I'd say, the confidence at this time in the results is low. But there seems to be a consensus across them that we might see a decrease in the frequency of extreme Santa Ana events, especially later in the season. And that may or may not be the case. But what we're seeing right now, I think, is that that's an incremental change over time. And what we have right now is sort of a nonlinear change in the length of the fire season in specific years because of this increased variability in precipitation, right? If it's only half a dozen or 5 big storm events of the year that bring in most of the precipitation, and you don't get one in the fall, or you don't get a couple in the fall or early winter, suddenly you have this much longer fire season. And that's what we're seeing every so often right now. So if Santa Ana winds become a little less extreme or a little less frequent for a particular part of the season, 10, 20, 30, 40 years from now, that's really not having any detectable effect on the risk right now compared to the greater variability in precipitation and its interaction with the timing of when we tend to lose those storms.
Okay. And then on a related question, for you, Leroy. So this idea of alternating wet and dry years, creating these conditions that we saw in LA and the Marshall Fire that Yost mentioned. So is there any study suggesting that this is a trend with climate change of alternating wet and dry years?
There's a very recent paper out by my colleague John Abatsoglu at UC Merced that seems to indicate that. And again, this is something that is very specific to these lower elevation, drier ecosystem fires, right? So forest fires in California or the Western US in general are typically in mountains. And the fuel types are not as responsive on really short time scales. So if we're talking about grass and surface litter and shrubs, right, high winds over even just a short period of time can really make a dramatic impact in how flammable those fuels are. So this is very specifically an issue around these fires close to urban areas.
Okay. And Kevin Gurney, I see your hand raised. Did you want to just unmute and ask it directly?
Yeah, thanks, Bart. I was intrigued by Leroy Westerling's comment towards the end of his presentation, because we talked a lot about sort of individual structural hardening and defensible space, but I'm curious about the one level up, sort of the urban planning scale. And he mentioned the urban wildland interface, and I'm wondering, what if there is work to be done there, because I think of a lot of urban areas will have, riparian corridors that enter in a fragmented way into a city, both because they're hard to build on and because they're attractive for all sorts of other reasons. But I'm also wondering about things like urban parks, urban green spaces. They're also, highly desirable. Do they then pose a tension and a threat in places where there's more drying and fire-prone type weather? Thanks.
Yeah, I think it's definitely an issue. I think you could see some of the impacts looking at the spatial spread of big coastal Southern California fires and those fire seizures in San Diego County, for example, in 2004 and 7, right? So we have those kind of corridors sort of running east to west, and they're not that wet. Even if we think of them as riparian that time of year. And it's not necessarily something you want to clear all the vegetation out of if you have other values that you're preserving by keeping it there in the first place. So that's definitely an issue to address. Another is just the pattern of new development, right? So the extent to which more of it is infill and not expanding the wildland environment interface is going to limit the growth of our vulnerability to this exposure.
Yeah.
I got other points
Go
on
ahead,
that.
Roy.
We've been talking about this in some of these LA County Commission that I sit on. The idea of parklands and the like, the issue is to Leroy's point, will it be irrigated? What's actually in that space? Well, there's proposals right now for avocado orchards to be put in as fire breaks. Few reasons behind that, maybe because people want cheaper avocados, but I think it's driving down this element. It has to be irrigated. I think one of the other pieces that's going on in the development side in terms of land use that some find, some might take exception with, this idea that because all these homes are at high risk, how do you protect them? Take for example, there was a picture shown in Alan's presentation of a mobile home, manufactured home park. There's nothing we're going to do to protect that once fire gets in. And so there's some folks that are now describing, then should we be building new homes that are perfectly built and spread apart to create buffers? Would perfectly constructed, and I put that in air quotes, communities become a passive fire break so that when fire comes in? I don't view it as a binary answer one way or another, but I think there's going to be a whole lot of conversation. You can put density in. What is very clear is you should not be putting density up against that fire risk.
Yeah, there are a number of different things that you can do in this space, and California is just trying to do a number of them. A good example of this is the town of Paradise, which is basically is wiped off the map, and so they were given an opportunity to rebuild. And one of the things they were trying to implement is basically a green belt around the town that they can then manage that vegetation and create some wildfire resilient spaces around that town to give them a buffer from the wildland. Another thing you can do on like smaller scale is, if you've got a flammable area, if you're building on the edge of a canyon, put the road next to the canyon instead of the house next to the canyon. Provide yourself a fuel break in that sense. So there's a number of things that we can do, and California has developed, best practices guidance for that as well, to try to, improve our wildfire resilience at the time that we are designing these communities and not just going back afterwards. I think that's the best situation is when we can start over and start afresh and integrate these principles from the very beginning.
Okay, Roy, did you want to add anything?
Nothing additional, thank you.
Okay, Yost, there's a couple questions for you. So the first one's from Neil Donahue. The VOCs are obviously absorbing into and onto something in the house. Do you know what, and can that be controlled?
Yeah, that's a really good question, Neil. The short answer is we don't know, but there are a few things I can say. We've looked at in our laboratory at painted surfaces, and we know that chemicals can diffuse into those surfaces, and then they'll come out at a later time when the air is cleaner again. But we would expect that to be faster than what we saw. So we don't think it is painted surfaces necessarily. We didn't see much of a difference between compounds with a higher or lower vapor pressure, as your follow-up question might have been. So the most volatile compounds like benzene, they also took weeks, just like higher molecular weight compounds. So it's almost like it's a physical release, and reservoirs we're thinking about are materials like drywall that is porous, and there's a large volume in most homes. But that's just an idea, and more research is needed to research this. Yeah.
Okay. And just one more question. In addition to the use of portable air cleaners, has your research looked into best practices for cleaning homes post-fire?
Yeah.
And what do you make of claims that wildfire smoke permanently damages walls, insulation, contents?
Yeah. So let me distinguish here between the gases that you smell and the all of the ash and soot indoors. So for the gases, a filter can work really well, but what also works well is just time. What we saw in our case was that sort of 4 or 5 weeks after the fire, the concentrations have steadily dropped to a point where they're really more normal for indoor air. And now more research is needed on this, but it does suggest that with time, this issue will go away. And during this time, you can protect yourself with air filters. So that's the things you can smell. And then there's the ash and soot that also accumulates inside homes. So research I've seen after the Palisade and Eaton fires show that wet wiping surfaces can do a good job of removing these toxics like metals. But what about softer surfaces? That is something that a lot of people are concerned about: couches, clothes, etc. Our research didn't specifically address that, so I can't address it in a lot of detail. But a lot of what the remediation companies are doing, like cleaning with HEPA filters, is common sense, and should help to address the issue. Will it get completely rid of it? That's an area where I think more research is just needed.
Okay, thank you. Roy, so a question for you is, what specific work or opportunities to partner are actively happening to align fire risks in the insurance industry to promote resiliency planning?
That is a question that it has so many dimensions to it. I'll see, you look at, in the California context, there's something like 140 insurance companies writing in the state, and each company approaches risks in different ways. What is clear is risk and price are correlated. And so when risk can be brought down, price can be addressed in that space. I will tell you that I work across a whole set of property insurers who readily use and embrace the research in this space as they manage their risk profiles. But without taking 10 minutes to unpack it, there are other things affecting price, particularly in California, where there is a particular regulatory regime that has been causing some of the turbulence in the insurance market. Wildfire just becomes an overlay in that risk. You need to address the insurance system, not just the wildfire risk.
Okay, thank you. So Alan, a couple of questions for you. So Bernadette, one of our members, said, you guys are a fantastic organization with lots of great data and info. How are you working with other Western states? What tools are available more broadly across other states, including Eastern states where fire behavior is different?
Well, there's certainly an exchange of information and best practices that happens through organizations like the National Association of State Foresters or the Council of Western State Foresters, where the fire chiefs from these respective organizations to get together and share best practices and lessons learned. Like I personally have met with state officials from Colorado, Oregon, Washington, up into British Columbia. We have MOUs around forestry issues with the West Coast states. So there's a lot of data sharing and science sharing, as well as best practices, and also sharing of resources when there are wildfire events. We will send folks up to Oregon, to British Columbia, certainly during the LA fires and other fires. We get firefighting resources from those other states as well. And part of that exchange is about learning. You know, when you are sending those firefighting crews over to these other places, you're learning how they do business. You know, that's certainly a part of why we get people coming over here to California, is learning from our best practices. And this happens very much internationally as well. CAL FIRE gets contacted from national and subnational governments around the world where they want to send folks here to learn from us. Costa Rica, Chile, different Mediterranean climates, all sorts of different places want to learn from us, and we're very willing and happy to support that.
Okay, and a question from our chair, Brad Coleman. So the pre-deployment to address the LA fire threat was impressive. You know, you mentioned the over 100 engines and many more personnel, yet we still observed tremendous loss. Are we better off investing in code changes, retrofits, structures, et cetera, or other financial incentives to prepare for these events?
It's all of the above. To be honest, we have to do everything. We have to invest immediately in firefighting resources because we have a problem that we're not going to be able to solve immediately. We certainly do need to improve our built environment and create more fire adapted communities around in the state. And as you know, we've talked to or mentioned several times already today, that's going to be a very long and vexing problem to solve. At the same time, that we also need to focus on our wildlands and our forests as well to resolve some of the smoke issues. You know, it's great if we can protect our communities, but that won't necessarily protect them from the smoke and public health impacts as well. So we need to certainly invest in more wildfire resilient communities. We need to invest in more wildfire resilient landscapes, and we need to have more firefighting resources. But firefighting resources alone will not solve our problem that we have. Leroy, do you want to add something?
Yeah, it's just the more extreme the conditions get, the more harder it is to adapt to them. So we also need to mitigate climate change and slow it down. So.
Good point. Very good point. Alan, one more question for you, and maybe for the broader group as well. So you mentioned you have 1,100 cameras on ridges to help identify fires. Has there been any effort to use satellite data to kind of fill in gaps or enhance it or use them by standalone?
Yeah, satellites is certainly the next step, and yes, there has been some initial work, and I think they're beginning deployment of a satellite network to do that. That will allow us to do this statewide and nationally. And so yes, that is certainly the next step. There's a lot of different exciting technologies that are being explored, from some like autonomous helicopters and other sort of like drone operated firefighting. You know, we have one of the programs I oversee is investing in new technologies. So that includes basically a robot to do prescribed fire for us. It kind of looks like a Zamboni that drives around and burns the landscape. So there's a lot of different tools that I think wildland firefighting and also our land management is hopefully going to look very different in 20 years than it looks right now.
Okay, it's good to know. And then just a general question for everybody. One of our attendees is worried about people in isolated areas, what they must do to avoid fire reaching them, and then also worrying about not just the direct effects of fire, but the indirects like smog and so forth. Is there any resources available or other communication mechanisms to help avoid those impacts for more isolated and rural communities?
For sure, in California, we have Ready for Wildfire, and if you put Ready for Wildfire into your computer, it'll take you to a webpage with a comprehensive list of resources to help you prepare for wildfires.
Okay, and is that just available in California, or?
That's a great question. I know that it's a thing that we have pushed. I don't know to the extent to which it exists nationally.
Okay. And then Leroy, I think a question for you was about trends or other from climate change for vapor pressure deficit?
There's actually a bunch of studies that focus on vapor pressure deficit. So people have looked at a range of different drought indices. They've looked at relative humidity, specific humidity, vapor pressure deficit. In almost every case, doing a climatological study on broad spatial scales, talking about estimates. So they're all basically driven by the same temperature and precipitation gridded products, right? But yeah, so there are historical estimates, and they do indicate increasing aridity and have been directly linked to, in particular, the growth of area burned in large forest wildfires around the western U.S. and in
Okay.
California.
Okay. And then another question for the group is there any work on cloud seeding to potentially help with, reducing drought? I mean, was that realistic for LA since we knew Santa Ana's were going to come at some point? Okay, yeah, it's
Not a thing that the CAL FIRE has invested in. I know
Okay.
that there are Western states that do engage in cloud seeding.
okay. And yeah, it seems a bit outside our expertise. Roy, there's a question, is there a way to incentivize more prescribed burns? We have like over 100 million, maybe 150 million dead trees in California. They're eventually going to burn. So
Yeah, I don't know that we need incentives for it as much as we need funding and political will. That's really the answer. Is we collectively, it's been used a couple times. It's an all of the above kind of place. And dead trees are fuel and kindling. How do you deal with those pieces? Clearly, there's ways to address that. Those fuel loads then drive the kind of fires. And then we particularly look at those concerns as they are very near to communities. I think one of the difficulties, and this is why I said it's about funding and political will, sometimes it's more ideologically driven constituencies, but oftentimes we're dealing with the communities themselves. People located to a community because of the aesthetic that was in that community and the adjacent areas. And when you start describing ways to change that aesthetic, even if you're describing something that says, well, this was the aesthetic 80 years ago, political will starts to erode pretty quickly.
A fundamental issue is that we have developed a society and culture in California that is came up in a time which was out of step with our historical fire regimes in California. This is less of a problem in LA, where LA has, in Southern California, its chaparral systems have experienced maybe more fire than they would have historically. But throughout much of the West, the 20th century was a place of abnormally low fire activity because of our land management practices, because we were suppressing, removing indigenous fire from the landscape. And so now when there is smoke in the air from a prescribed fire, people think that is unusual or harmful. They are used to forest densities that are much higher than they would have been prior to pre-European settlement. And so our expectations as human beings, based on this recent context, are probably out of line from the historical average of what they were prior to widespread Euro-American settlement of the American West.
Okay, thank you, Alan. One more question for you, Alan. Has there been any effort for maybe using crowdsourcing data for early detection?
I mean, to some extent, yes, that happens. Whenever you see a fire, somebody should call it in and let that know. Let them know. Yes. As far as like to the cameras themselves, I'm not sure that we've tried to pursue
Okay.
that as a state. And we have this AI tool that we think is pretty effective at doing that. And so that's the path that we're going down.
Okay, yeah, hopefully people see a fire, they'll report it. There's a couple health related questions, and see if anybody's willing to take that on, and Jonathan, we have Jonathan Patz from our board that may be able to help us on this as well. So there's a question of, has there been any research on the number of people who suffered health consequences from toxic smoke? So either big population studies or any clinical studies. And then there was an earlier question about, is there any insights from agricultural burning, or is that a good analog?
I can take that on a little bit. I actually meant to talk about this a little bit more during my talk. So just some rough estimates in the immediate wake of these fires, and Dr. Patz, you can correct me further along after I speak. Was that so? The Camp Fire burned in 2018. There's epidemiological evidence that there are 85 people who died directly in the Camp Fire, but epidemiological evidence was like more in the low hundreds from smoke impacts from that. And then in 2020, there were some Stanford estimates that between 1,000 to 3,000 people, or 1,000 to 3,000 premature deaths from smoke from August through mid-September of that year. So these are tremendous numbers. The health impacts of smoke, I think, far exceed the environmental impacts and the direct damage impacts of wildfire, and are very complex in terms of like lost work hours, lost school, childcare, things like that. Really widespread impacts of this.
Yeah, I'll just add, great answer, Alan. There have been some very broad international studies on short-term exposure to air pollution, a lot related to wildfires, but not exclusive. And the estimate is 1 million people die prematurely globally from acute exposures, including wildfire smoke. The other thing is that it's very concerning for pregnant women, and studies coming out of Australia looking at bushfires are showing adverse birth outcomes from pregnant women. So that's, it's a big deal. And the health impact is far beyond the acute event itself.
Okay. Thank you. And we have 2 minutes and 2 final questions. So has anyone been studying East Coast wildfires? Probably Leroy or Roy might be able to answer it. So I think some of the ones we've seen recently have been unprecedented. And then, certainly the Eastern US is more densely populated and can be windy. Maybe it doesn't have the dry conditions that are conducive to fires, but is that an area of concern?
Briefly to the pieces, the conditions are in place to see such a thing. The flash drought with some winds. You'll hear tomorrow about some pieces from Helene. There is a particular concern given all of the downed trees in the western part of the Carolinas in terms of those pieces. You go back to 2016, the Gatlinburg fire, and so there is some precedent for it. Last year, there was a series of drought in the Southern Appalachians that were very conducive to it. But absent the Gatlinburg fire, we have not yet had an East Coast conflagration driven by wildfire. I think the reality is that we just haven't seen it yet. Even this past year, there were wildfires just outside of New York City. Okay. They did not quite know what to do with it, so they sent city fire trucks. We don't have time to go into it, but you fight city fires differently than you fight wildfires. It's different training down those lines. It's a when, not if question.
Okay. Okay, one final question. Alan, you may have partially or completely answered this already about the use of indigenous knowledge.
It's very important. It's a thing that there are over 109 federally recognized tribes in California and dozens more non-federally recognized. A lot of these tribes have very limited capacity, but are very strongly interested in engaging in wildfire resilience activities, putting more good fire on the ground, along the ways of their historical lifeways that, they have been managing with fire and putting fire in the ground since time immemorial for thousands of years. And our ecosystems in California are frankly adapted to that level of fire activity, and empowering those tribes is the thing that we're trying to do in California. I have a grant program that's around tribal wildfire resilience, where we're trying to increase tribal capacity to do just that.
Okay, great. Okay, well, our case study is at an end. I want to thank the speakers for just a fantastic group of presentations. So now we're on a 15-minute break and come back at 3:15 Eastern Time to listen to the Phoenix Extreme Event Heat case study. Thank you, everyone.
There to get your questions in there, but not only get your questions in there, but what Slido allows you to do is look at other people's questions and upvote them. So it's kind of fun. You know, if you, I don't know if you can cheat. Can you vote more than once on a question? But anyway, so upvote those really good questions, get in there and play in Slido, and let's have a great set of questions. So without further ado, it is with great pleasure I get it. Phoenix Extreme Heat is our next case study, and it's a great pleasure to introduce fellow board member Bernadette Woods-Plackey from Climate Central. Go for it.
Thanks, Brad. Well, I have to say, we have a great crew lined up for this one too, so I expect it to be an equally good conversation. The reason we decided to focus in on this event when we were preparing for this session was this. Heat is our easiest type of extreme weather to forecast, yet it's our deadliest. And we know that we're undercounting the number of deaths, and that's just not okay. That doesn't mean there hasn't been amazing work done. There really has been, from advancing research and science, technology, innovation, applying proved adaptation, planting trees, incorporating shade, using different materials, also how we're forming partnerships and community engagement, leveraging communication through many different ways, and new policies to keep outdoor workers safe and protected, in addition to kids and other communities. So there's a lot of really good work being done, but we have more to do. Phoenix is a city that's always been hot, but the frequency and the intensity of the heat is changing. And even for Phoenix standards, this past summer set yet another round of records. In this session, we're going to take you through a case study of the extreme Phoenix heat, from the weather forecast, how that's changing, how one of the country's only heat offices prepares and responds to what's happening around the community. And we're going to hear from a team that is thinking about the built environment, how we can be more resilient, and also our health. We know that our health is being greatly harmed by the increasing heat. In this case study, of course, is going to look at that dry type of heat, but Lisa will expand some of her learnings to other places have more of a humid heat too. So a huge thank you to our panel. We're going to start with Amber Solon. She's the chief meteorologist at ABC 15 in Phoenix. Then we'll go to David Handula, who's the director for the Office of Heat Response and Mitigation for the city of Phoenix. And he's associate professor at Arizona State University. Then we will move along to David Saylor, and he is also at Arizona State University because they're doing some great work. Director of School of Geographical Sciences and Urban Planning. And then we will wrap it up with Dr. Lisa Patel, who serves a double perspective here too. She leads the Medical Society Consortium on Climate and Health. She's also a clinical associate professor at Stanford University and still a practicing doctor herself. So let's start out with the one and only Amber Solons.
Thank you. Can you guys all hear me okay? Thumbs up.
We gotcha.
Okay. All right. I'm going to share my screen here. Okay. Can you see it, Bernadette?
We see that we're seeing the full PowerPoint.
Yes, okay. Let's see if we can get it into play mode. You might just have to see it this way. Okay, hold on. Oh, there we go. I had too much blocking the front of my screen. Okay, so here we go. All right, so as Bernadette mentioned, I'm the chief meteorologist at ABC 15 in Phoenix, and on the forefront of the changing climate in terms of heat, because Phoenix, as Bernadette mentioned, is one of the hottest places in the country and getting hotter. There's my contact information on the screen if you need to find me. I'm really easy to find, my email address there, and then on almost every social platform you can think of, you can look me up there as well, and also see some of the extreme heat stats that I share often with my viewers here in Phoenix and others across the country. So this is just a recap of what was the hottest summer on record in Phoenix. And by far, in some cases, the amount of triple digit days, 100-degree days, was 143. That was second only to the summer of 2020 when we had 145 days. And 2020 was kind of what I would consider a tipping point year for Phoenix in terms of extreme heat. That's when we started not just breaking records occasionally, but shattering them consistently. And we continued to break even those 2020 records in 2023 and 2024. So last summer we had 122 days where the temperature hit 105 or hotter. That was the most on record. It beat the 2020 record by 20 days, not even close. Perhaps even more shocking was the amount of 110-degree days. We had 70. That beat the 2023 record of 55. Back in 2020, the record was in the low 30s. And prior to that, it was in the teens. So we are just seeing these records really accelerate. And again, not just breaking them by a little bit every once in a while, but really just shattering them. The amount of 115-degree days was 12. That was the third most on record. The record was set in 2023 of 22. So again, really extreme heat here in Phoenix. We also broke the record for the consecutive number of days at 110 degrees or hotter. So that's the amount of days in a row where we hit 110, 111, 112, anything at 110 or above. The new record set just last year was 31 days in a row, over a month, where the daytime high was at 110 or hotter. And that broke an old record from the 1970s of 18 days in a row. And again, broke it by a long shot, not even close. So part of the way that I look at kind of contextualizing this for my viewers who are on average not scientific, in a lot of cases we're talking about, high school education level or lower, to really show these extremes and frankly to get it on a graphic that it would fit to put on air. I started looking at what we were doing every 20 years. So this is the trend of the number of 115-degree days per 20-year period. And you can see prior to the 1960s, every 20 years, we only did about 7 days at 115 or hotter. In the period from 2000 to 2019, we did 42. And now this next 20-year period, which we are only less than 5 years into, we've already done 56. So you project that out, we could be close to 200 if we consider that the warming trend is going to stay consistent, but we may beat that because what we're seeing here is that the warming trend is not staying consistent, it's actually accelerating. Same things in terms of overnight lows. So we're not just talking about extreme heat during the day. When I was growing up here, it was really just 3 or 4 hours a day for 2 or 3 months out of the year that you had to try to deal with this extreme heat. But now it is 24 hours a day, 7 days a week for 4 or even 5 months out of the year that people have to survive these incredibly hot temperatures. So again, these are 90-degree lows broken down into 20-year periods. You can see prior to 1980 and the entire historical record from 1900 and even beyond that, if you go back to when records started in Phoenix, the late 1800s, we didn't have any 90-degree lows during that period, so I just didn't even put them on this chart. But prior to 1980, we had only 9 nights in the entire historical record of Phoenix where the temperature in the overnight hours was over 90 degrees. From 2000 to 2019, we had 176 nights with lows in the 90s. And again, less than 5 years into this next 20-year period, we have already had 122. Last year, 39 nights with lows in the 90s. 39 nights where we were running the air conditioner throughout the entire night because it was just unsurvivable otherwise. 90-degree lows and 110 plus highs, that's no relief. And it's no relief for months at a time. So why is this happening? Well, I'm sure a lot of you are aware, it's really a combination between human-induced climate change and the expansion of our urban heat island here in Phoenix. The Phoenix metro area has grown significantly in the last 20 to 30 years. We are paving over desert areas. We are building buildings that trap heat. And now we are seeing about a 5 to 10 degree difference in overnight temperatures from the areas at the center of our heat island in Phoenix to outlying areas here across the Phoenix metro area. So temperatures are getting hotter. Now, the other factor in all of this is our monsoon season, and I need to address that because the monsoon season is something that happens every summer. So during the hottest time of the year happens to be Arizona's stormiest time of the year. And what happens is we get a ridge of high pressure that moves in from the east. It's called the Bermuda High. And over the course of weeks or months, it gradually migrates from out in the Atlantic all the way up near the Four Corners. And what that does is it opens up the flow of moisture from the south. So we bring in that southerly moisture, we raise dew point temperatures and humidity levels, and then when we get this extreme summer heat, that heat forces the moist air to rise, and we get thunderstorms. And they happen almost daily in up across the higher terrain, and then they come down into the valley some nights and cool things off and bring much needed rain. If we get a good monsoon season, we will not be as hot. But what we're seeing is changes in our monsoon season as well. And if you look at the right of this graphic here, you can see that monsoon ridge, that high pressure, it's historically been rather tight over the desert Southwest. That circulation has been rather tight. What we're seeing is that this monsoon ridge is expanding. It's expanding in time and in space. And what we're getting is big heat domes that block out the moisture completely. So instead of it flowing around and coming right up into Arizona, the dome is so vast that we're not seeing that moisture come in, and we are just baking under that sinking air, that ridge of high pressure that is just becoming stronger. So Dr. Christopher Castro has done a lot of research on this. This is from one of the papers he co-authored with Lammers back in 2016. I just spoke to him in depth about this again last summer prior to our hottest summer on record, 2024. And the research is pretty much the same. So I think, we could use with a little more in-depth look at how this is changing and perhaps a little bit more lead time on as we go into the summer months, what we expect the monsoon to be so that we can prep for even hotter summers if we know ahead of time that this ridge of high pressure is going to be too spatially expansive and our monsoon is going to be a failure. And I do want to show you, of course, the hot and dry go hand in hand. This is just a snapshot of what we call jokingly call our non-soons instead of monsoons. These are monsoon seasons with little to no rainfall. And 2023, we only got 0.15 of an inch. Just to kind of put that into perspective, normal for Phoenix would be around 2.5 inches. I think the latest 30-year normal that was recalculated in 2020 was 2.43 inches. And that was a reduction from the previous 30-year average of more than 1/4 of an inch, which may not seem a lot to folks on the East Coast, but here in Arizona, a reduction of 1/4 of an inch in monsoon rain is significant. So we know our monsoon is drying out. And again, from about, I think it was 2.71 to 2.43 was the reduction in the average that we got when we redid our 30-year averages in 2020. And again, those are some of our hottest years as well. Both 2023 and 2024 were among the hottest and driest monsoons on record. Okay, well, it's not just the summer. It's not just the monsoon. This heat is now stretching into fall. And last fall, our hottest fall on record, we broke an old Dust Bowl record for the most record-setting days in a row. So that old record was 14 straight days of record heat in Iowa back in the 1930s. And Phoenix did 21 straight days of record heat from September 24th to October 14th. We broke a daily heat record every single one of those days. We broke the hottest October day on record, 113 degrees, which we did on the 1st and the 6th. And previously, the hottest we had ever been in the month of October in Phoenix was 107 degrees. So we beat that record by 6 degrees. We also saw the latest 110-degree day on record, October 7th. We were at 110 degrees, October 7th. That should be shocking. It was to us. Here's just a snapshot of September and October and where those temperatures stood. You could see we did have some good days in there where the heat was significantly reduced right around mid-September as we ramped up some moisture and got some storms in here. But other than that, it was just absolutely brutal. And again, some more records broken, 117 degrees on September 28th. That broke the daily record for September 28th by 9 degrees. And again, we went over some of those hottest October records as well, but there's what it looks like, the calendar view of just how intense our heat was. So this is starting to really impact things, not just during the summer months like Phoenix is accustomed to, but into the fall months as well. It's affecting kickoffs for ASU football. We had a 107-degree kickoff at Sun Devil Stadium, and these are kickoff temperatures at 7 o'clock at night. It's also impacting fall sports for kids. My son plays football, and he had a football game scheduled on that 117-degree September day. And we pulled him because it is just not safe. So I want to talk just a little bit about the impacts to school recess and sports, because I think this is something that we need to look more deeply into. Many of the school districts in Phoenix actually start classes in late July or August. So even if you're on what would be considered a typical school schedule in Arizona, you're starting in August. If you're in a district which is semi-year round, that gives their students 2 weeks for fall break, 2 weeks for spring break, and about 6 weeks for summer break, you start classes in mid to late July. So these kids are going back to school during the hottest time of the year. And although some public school districts may have heat contingency plans for what they're going to do at recess or for after school sports, they're not uniform throughout the state. They're not uniform throughout the city, and they're not in sync with each other in a lot of cases. Different districts have different standards. We also have a growing issue here where we're seeing massive flight from public schools and into private or charter schools that do not have written plans to address heat at all in some cases. And the same goes for club sports leagues. When we were having that 117-degree day in September, I started emailing all of the club sports leagues I could get contact information for, just to let them know what the forecast was going to be and how dangerous it was going to be, and asking what their heat contingency plans were. And a lot of them did not have heat contingency plans and just wanted to go on as usual. They'll just drink extra water and deal with it. Other districts, thanked me for telling them and either canceled or rescheduled games. And others just canceled games in the afternoon at like 2, 3, 4, 5, to which I say, you really need to consider what time of day you're playing these sports as well, because in the middle of the day at noon, it's even hotter than it feels like out there because the sun is shining directly on you. So if the temperature reads 107, it is feeling a whole lot hotter to you at noon in 107 than it would if you were outside at 107 at 6 or 7 p.m. So we need to take into consideration sun exposure, sunburn, all of these things. And of course, the dryness of the air, which gets me to kind of the next point. Even the heat contingency plans that I found were based off criteria that we don't use in Arizona. We don't use the heat index. Our air is so dry that it doesn't matter for us. We use actual temperature. We don't use heat index. And we don't use heat advisories. The National Weather Service does not issue heat advisories for the Phoenix metro area. They issue excessive heat warnings, which have now been renamed just this year, extreme heat warnings. And so the heat contingency plans will say, if a heat advisory is issued by the National Weather Service, we will do X, Y, and Z. Well, a heat advisory is never going to be issued by the National Weather Service in Phoenix. So where does that leave us? So these are just some of the things that I'm thinking about as a parent and as a meteorologist as our heat grows. The other thing is we know that there are impacts to mental health. We know that it can lead to increased anger, shortness of temper and patience and rage. There's kind of a little bit of a seasonal affective disorder here, kind of reversed, like too much sunshine, too much heat. We are inside for months at a time, like other places would be in the winter time. And that could lead to depression. And here are just a few headlines I kind of threw on the screen of some studies about how heat impacts mental health. We also tend to see an uptick in officer-involved shooting incidents in the Phoenix area when we have hotter temperatures. Of course, there's impacts to the economy and personal finances. People just do not go out as much here in the summer. Restaurants are not as busy. Fun outdoor places are not busy. Utility bills are going up. AC is running 24/7. The average size house in Phoenix with just regular AC usage. We are not talking about excessive here. We're talking about maybe keeping the thermostat at 78 degrees and not going lower than that. You would still get a $300 to $500 a month bill, depending on who your provider is, each month in the summer. Many people cannot afford that. Now, our utility providers like APS and SRP, they do have programs to help people pay their bills, to kind of float them for a while, to get them through a couple of months and make, either smaller payments or, just kind of get you on some kind of a payment plan. But the fact is that the rates are going up and people are not able to afford it. And we have a lot of older people here, and AC is getting shut off if they can't pay. And it's not happening all the time, but it's happening enough that we're seeing deaths. In fact, this is a story that we just reported on the 1st of this month. An 82-year-old woman died in her home. So we're not just talking about outdoor heat deaths. We're talking about indoor heat deaths. Her AC was turned off. The power provider said that they tried multiple times to contact her, but they admitted to our reporter that they never actually spoke to her. They just attempted to call, and after so many attempts, they shut off her power and she roasted in her house and she died. And now the family is suing. So we're seeing, more and more cases of older folks that are either not paying their bills or not turning their thermostat down enough to actually help keep them alive. Now, I know that the city of Phoenix, and David Hondula is going to talk more about this, the city of Phoenix and Maricopa County, they're doing a lot. They have a heat death dashboard like this that they put up where they show us, the total number of confirmed cases, the ones under investigation. This is a new tool we've just gotten in the last couple of years that's helping us keep track of heat deaths. But we are still really underestimating the amount of people that are dying in this heat and across the country. We need a standardized way of reporting heat deaths across the country, and heat measures need to be taken in every city, county, and town. And David Hondula will probably talk about what Phoenix is doing and how it's a model for much of the rest of the state and the country, but we got to expand this into other areas. A lot of Arizona is rural. I also would advocate that we have to decouple heat response measures from excessive heat warnings. In Phoenix, when we have long stretches of excessive heat, these warnings may be out for like 8 to 10 days at a time, and the National Weather Service may drop them when we go to 108 or 109 and then put them back into effect at 110 plus. 108 and 109, those are still life-threatening temperatures. So we need to have all of our heat response measures, everything up and running, even if these excessive heat warnings are not into effect. And again, we're going to focus on heat risk. The CDC just adopted this. This heat risk tool was developed by a meteorologist at the National Weather Service in Phoenix about a decade ago. It is now nationwide, and it's what heat response, or I should say what heat warnings are based off of, is this heat risks to our health. But this is only going out 7 days. And I think in order to get the planning out and resources out into rural communities across Arizona, we need longer than a 7-day lead time. So that's my comments on that. And again, I just want to say thank you so much for having me and for talking about the heat problem that we're having in Phoenix. We don't want to be the poster child for heat deaths, but we are. So I'm glad that we have, people's eyes and ears on this issue so that we can hope to find solutions. Thank you.
Thank you, Amber. And she set it up beautifully for Dave Hondula to come on. And this is what happened in our prep call. We wish we could have brought you all into it. They work closely, and that's why Phoenix is doing some great work. Sadly, there's still too many people dying. So at this point, we're going to hand it over to David Hondula, who'll take us through one of the very few heat offices that exists in the world. And so he's going to teach us what he's learned and what can be applied elsewhere.
Thanks so much, Bernadette. Just look to see that you can hear me okay.
Yes, we
Yeah.
can.
All righty, thanks. And yes, good afternoon from Phoenix, where we are below or at about 70 today, but we are 5 days into our operational heat season for 2025. Really honored to have the chance to join you all today. I'm going to share the slides I've prepared are very programmatic focused to help the board and our audience understand how the city is trying to respond to the conditions that Amber just so eloquently described. And as we move into the discussion, I'll have some additional ideas to share about research questions, needs, and where we see the gaps are on implementation. As Amber alluded to, we have a unique or at least rare opportunity in Phoenix where we have a dedicated office as part of the local government structure focused on heat. We're about 3.5 years old, initiated by our mayor and city council, who recognize the priority that heat is, echoing the themes and sentiment from Amber's presentation. The heat office team is, let's see, we are now 9 strong, part of the city manager's office at the city of Phoenix. But as I'll describe on the slides here, heat is certainly an all hands on deck effort. I want to briefly acknowledge at the start of the presentation that what I'm going to talk about in the rest of the slides is not the whole story. I'm going to spend most of our time today talking about immediate life-saving strategies that we're trying to deploy to cope with summer heat. But as Amber mentioned, and as we'll hear from other speakers, we need to be thinking both short-term and long-term simultaneously. And our office is engaged with many other city departments, and indeed a much broader set of partners on initiatives like providing more shade, whether it's natural shade or built shade, or testing out and deploying innovative surfaces. And I'm sure we'll hear some of that from Dr. Saylor in a few moments. So there is a big portfolio and portion of our thinking about long-term strategies to cool the city and make it more comfortable inside and outdoors. But today, in our time together, we're going to focus on the short term. What do we do during those 30 plus consecutive days of 110, or the nearly 5-month season when we are in what could be defined as a heat emergency, at least with a lowercase e? One of the actions that the heat office has helped lead since we came into existence is writing and updating the city's annual heat response plan. And our experience here in local governments and research shows that this is true all across the country, really parallels what Amber was talking about with schools and the incompleteness, underdevelopment, or complete absence of written plans. Research by our colleagues Sarah Miro, Kelly Turner, Ladd Keith have been looking at this from a national perspective. And on the whole, heat plans are quite underdeveloped relative to plans that we have for other hazards. We've been working to change that story in the city of Phoenix. We have a heat response plan that has been unanimously supported by our city council every year. And it divides approximately 30 actions into the 8 big buckets that you can see on the slides here. This is how we are building a framework around our heat response. And we think about heat response very broadly, including the immediate life-saving work of our paramedics in the field who use some innovative techniques for responding to patients with severe heat stroke, to opportunities for recreation. The operation of our city swimming pools and splash pads, for example, is in the boundary of our heat response plan. This is work that is conducted with a really wide range of partners. Just a few of the logos on the slide. ABC 15 should certainly be on here, Amber, and all of our media partners in helping communicate what the risks and resources are. All levels of government are involved in heat response now in the Phoenix area. Academic partners, of course, the Weather Service, and many more. And we'll highlight a few of their roles as we move through the slides. And we're really proud of this slide as well, bringing more and more city departments into the mix. I think one of the hardest parts, or maybe most interesting parts of taking on this role in the heat office, is that heat seems to be somewhat of a boundless problem. It's hard to find city processes and functions and roles that aren't connected to heat in some way. So we are really adopting a big tent approach to try to address this big challenge, and a big public health challenge it is. Here in Maricopa County, we are very blessed to have an excellent heat health surveillance program that provides detailed intelligence that drives what we do. I wish we didn't have such a great program. We have such a great program in part because we need such a great program, because the public health impacts of extreme heat are so high. Amber was talking about the underreporting of heat deaths and the need for consistency, and I would argue that Maricopa County's model is indeed one to look at as we think about improving heat surveillance and reporting all across the country. Our epidemiology team and the Office of the Medical Examiner all work very hard to try to understand what the impacts are. And you can see the numbers here over the past decade plus. Coincident with, but I would argue not fully attributed to, the increase in extreme heat that we've seen over the past decade. We see an increase in heat deaths as well, and a really remarkable increase. That this pattern here, we're talking about a several hundred-fold increase in heat deaths, outpaces anything we would expect related to climate, anything we'd expect related to long-term demographic changes in the population. And we'll talk about, perhaps in the discussion, about some of the factors that could be at play here, but over 600 in each of the last 2 years. The Maricopa County model, as I alluded to, provides some really detailed information. I have just some summary statistics here to give you a flavor for what's in their reports. A search for Maricopa County heat reports will take you right to the more detailed findings. Information about place of injury. Where are people encountering heat that is responsible for their death? About 3/4 of our cases associated with outdoor exposure. Amber alluded to, indoor environments can be dangerous as well, particularly among people who do not have operating air conditioners for one reason or another. So while we certainly need to be focusing on outdoor cases, indoor a really important part of the story as well. And if we're thinking about outdoor environments, we have to be thinking about people experiencing homelessness, who last year accounted for about half of our heat-associated deaths in Maricopa County. That is a tremendously high, disproportionate risk. We estimate that people experiencing homelessness, and especially unsheltered homelessness, are at something like 300 to 400 times higher risk of heat-related death, times, not percent, times higher risk of heat-related death than the rest of the population. So if we're thinking about moving the numbers for heat deaths, we need to be thinking about this particularly impacted population. And there is a high overlap in our cases, unfortunately, between people experiencing homelessness and substance use. About half of our heat-related deaths involve substance use in one form or another. And among those, which is what's shown on the bar here, over 80%, upwards of 90% have involved stimulants. So we're thinking about reducing heat deaths in a place like Phoenix, and I would argue these patterns are likely true across at least much of the Sun Belt, if not the entire country. If we are not thinking about what are the effective strategies for people experiencing homelessness, for people who are substance users, for people who are facing energy insecurity, I'd argue we're not really thinking about answering the right questions. This slide ties very closely into something that Amber referenced and recommended, that we need to be thinking about actions outside of those heat warning days. The figure is a bit complicated, but bear with me for just a moment while I walk you through it. The orange and blue lines at the top show daily temperatures last year, the maximum, minimum. The bars show the number of heat deaths reported on individual days. And I'll first draw your attention to what's on the horizontal axis, the fact that that axis extends from April to the end of October, a really wide season when we are seeing people suffer these very terrible outcomes related to heat. I'll then draw your attention to the color of the bars. And the color of the bars show how each day was categorized on the National Weather Service heat risk tool, which we are big proponents of and use operationally as well. The purple days and to some extent the red days are those when we'd be issuing the biggest warnings, using some of the most prominent tools that Amber talked about. But look at how many bars are colored other than purple or red, orange, or even yellow. There are a lot of heat deaths that occur outside of the days when we have those warnings in effect, our biggest, loudest tool. In fact, last year, over half of our heat-related deaths occurred on days when the National Weather Service identified the day as having moderate heat risk. So if we are not trying to communicate across 100, 110, 120 days of a heat season, we're going to miss the chance to save a lot of lives. What are we doing programmatically at the City of Phoenix to try to save lives? Again, we have this heat response plan that's been adopted by our City Council unanimously each of the past few years. And I'll share just a couple of example actions to try to give you a flavor for what this is like programmatically on the ground. Our paramedics over the past couple of years have been using a new technique in the field for patients who are experiencing heat stroke or severe heat illness. It is a rapid cold water immersion technique. It's a little bit grim, but you can see what it looks like there with the dummy in the photo. Somebody who has a very, very elevated core temperature is now immersed into ice and cold water in what is essentially a retrofitted body bag, and they will be cooled during transportation to the hospital. And we are hearing from our partners in emergency rooms, tremendously improved outcomes, patients who are already improving by the time they get to the hospital instead of being in a real life or death question when they get there. Last year, this was deployed over 300 times, and our fire department is working with the local health authorities to develop a more formal assessment of what the benefits are. We've been working with our fire department on some of the logistical components. Interestingly, ice, a big part of the challenge. How do you always have ice at the ready when you're encountering people all throughout our urban environment who are in this situation? Last year was also a really big one for the city in that for the first time, we made an investment in operating 24/7 and overnight heat relief sites. We repurposed some vacant space in one of our public libraries. We also had a senior center that would essentially change over at the end of business hours into a heat relief site overnight. Tremendous demand for these locations. More than 5,000 people came to these sites over the summer, accumulating more than 28,000 visits. And this was an all hands on deck staffing approach, really led by our Office of Homeless Solutions, along with support from local behavioral health and navigation services, health and medical services, including from ASU nursing students, and the security piece of the puzzle, so important as well. How do we ensure that the environment indoors is safe and that impacts are minimized for the surrounding neighborhoods, particularly during a time when, as Amber mentioned, people may be a little bit on edge or agitated. So we want to have a welcoming environment, but also a safe environment with the appropriate security presence. That's been an interesting needle to thread for us. We complemented the 24/7 and overnight operations by extending cooling center hours at additional public library locations until 10 p.m. Same idea here of a comprehensive staffing model, and also many thousands of visits recorded at those sites last year. And then just a couple of other thumbnails of examples here. A lot of water moves through our city and region. Well over 1 million bottles touched the City of Phoenix water distribution effort last year, and we're just a piece of the regional effort. The city is able to provide grants to community partners as well, recognizing that our reach is only going to be so far and that formal government may not have trusted relationships with every corner of the community we need to reach. We do provide support as a city for major events. Last year, we had the WNBA All-Star Game here in July. We want to ensure that residents and visitors to those events are safe. And we've really been thinking hard about communications and doing a lot more asking of partners, what will be useful communication tools for you? Some of the overdose prevention groups here in the region told us that small pocket-sized pamphlets they've found to be really effective in working with their client base. So we worked with them to develop the product you see on the screen there, and a companion version more focused on heat and substance use. And these went off the shelves by the thousands last year. What did it all add up to last year? We saw a 20% reduction in heat-related 911 calls to the Phoenix Fire Department, despite the heat that Amber mentioned, and despite more messaging than ever to call 911 if you're having a heat emergency. That decrease was even greater in the immediate proximity of our enhanced heat relief sites. We saw the first decline in heat-related deaths for more than a decade, but as Amber alluded to, we still have a long, long way to go to even get back to where we were a decade ago, let alone our goal of 0. And the last bullet point, I don't think can be overemphasized. Preventing deaths, preventing illnesses in the immediate is, of course, really, really important and what we're after. But through these efforts, we were able to achieve some other really big wins for community-wide heat resilience that don't look like an avoided heat-related death today, but probably will this summer. 900 or more people were connected to some type of additional service, including shelter and housing through the heat relief sites. As we sit here today, we know that at least 300 people are in housing in the city of Phoenix who were connected into that housing through their engagement at a heat relief site and might not be there otherwise. My last point I'll just acknowledge here, for those who are familiar with the incident command universe in emergency management, it's been an interesting evolution for us to try to work heat response into an emergency management paradigm when we have a heat season that lasts from May through October. In a traditional incident command structure, there's a daily cadence to the full cycle. And it's not practical for us to have a daily cadence 120 times here through all of the stages of the planning cycle. So our emergency management team has really helped us think creatively about how to be organized. We are now organized into what we call a weekly incident cycle, but we are essentially meeting every day. And this model, I mean, our emergency management team has done such a heavy lift here. We have transitioned from an environment in the greater Phoenix area where 5 years ago, emergency managers were standing up at meetings on heat response, asking out loud if it was appropriate for them to be there. They weren't sure if heat fit into their job duties. And now emergency managers are leading the charge on the field to implement the right structure that can help us respond to heat as thoroughly and comprehensively as we do for other hazards. And I think we are seeing some really positive outcomes. I look forward to hearing from the rest of the speakers and the discussion that we'll have. As I mentioned, we've just kicked off our operational plan for this season. We're 5 days in. The mayor will be speaking at a kickoff event tomorrow, and looking forward to the discussion. Thanks so much.
Thank you, Dave. Now we're going to hand it over to another Dave, also working at ASU on this, and he's going to expand upon that work and how it factors in how we build things, how we think about building things from the house to full communities and forward. So at this point, I'll hand it over to you, Dave.
All right, thank you. Just a quick sound check. Everyone can hear me?
We gotcha.
Fantastic. All right. Yeah, well, so thank you for that introduction. And I really do appreciate being invited to participate in this discussion today. So in addition to my role as a director of the School of Geographical Sciences and Urban Planning at ASU, I'm also the director of the Southwest Urban Integrated Field Laboratory, or Southwest IFL, sometimes lovingly known as SWIFL. And this is a 5-year project that is looking at heat through a slightly different lens than sort of the very urgent lens that Dave Hondula and his team look through. We're looking to try to understand extreme heat across cities throughout Arizona, throughout the Southwest in general, but also trying to understand what drives variability in local, neighborhood exposure to heat, and what possible solutions are there that can help us drive down the magnitude of extreme heat in our communities. And so with that as sort of an overview, that's the perspective I'm going to be taking in my brief comments. But before I start, I really want to emphasize that extreme heat is about much more than just maximum air temperatures. Obviously, that's what hits the news. That's what we're really known for is the days, how many days a year we're above 110 and so forth. But it's about so much more than that, not just in Phoenix, but elsewhere in the country. We care about nighttime minima temperatures in particular with respect to heat-related outcomes. We also care about relative humidity, wind speeds, solar radiation. All these parameters are really important drivers of sort of the urban thermal environment. But going one step further, these drivers also interact with the social and neighborhood highly variable drivers that help determine why some neighborhoods are 2 or 3 or 4 degrees Celsius warmer than others. And so in particular, we're interested in land cover and surface properties really as a lever to help moderate extreme heat. So a lot of the strategies that we look at in the Southwest IFL really focus on what can we do to land cover and surface properties to reduce the magnitude of surface and air temperatures and the overall, improvement of the thermal environment. Of course, when extreme heat happens simultaneous with technology failures, it can be truly an order of magnitude different type of episode. So we are very interested in simultaneously looking at heat with other disasters type activities, such as power outages or simple air conditioning equipment failure, which happen with much more frequency in extreme hot conditions. And of course, the outcomes. I want to point that we focus almost exclusively here today on health-related outcomes, and for a good reason. We have hundreds of people dying every year due to extreme heat in Phoenix, but it's important to keep in mind that there's a whole range of outcomes that we need to be concerned about as we think about developing our solutions to make the city cooler. Everything from heat-related morbidity and mortality, but to simple things like energy and water demand, or climate migration, seasonal migration, and so forth. We have this phenomenon here known as snowbirds, where people from the north come here in the cooler months, and how does that shift, and how does it affect economics, economies when our heat season is elongating? So getting back to the Southwest IFL and some of the work that we're doing, I just thought I'd give you more of a pictorial overview of the projects that we're exploring, and not so much on the quantitative side, but the general solutions and strategies that we're looking at are things such as building materials, so high solar reflectance materials, high thermal emittance materials, whether these are rooftops of buildings, walls of buildings, surfaces of shade structures, or parking lots. We're also looking at how urban morphology and the configuration of buildings, the space between buildings, affect things like access to shade, as well as the ability of air to move through our urban canyons, and the impact that has on air quality. And even though you might not expect it in the desert city like Phoenix, we do put a lot of emphasis on blue and green infrastructure. So urban lakes, or in this case, on the upper right-hand image on my screen, we use flood irrigation. Or for green infrastructure, whether it's trees or parks. We're interested in understanding how all of these strategies affect the urban thermal environment, but really through sort of two different, very important questions. First is simply the question of what is the local and downwind cooling effect of any of these strategies? So we're thinking, from a chronic perspective, how can we reduce the overall magnitude of heat in a neighborhood? That's important, but almost every one of these strategies that you could imagine has unanticipated consequences. Many times they're co-benefits, but sometimes they're disbenefits. And it's important that we, as researchers, really try to understand the totality of the impact that these strategies have on our communities, because ultimately we want to provide useful guidance to decision makers. So with some of the work we've done, we've identified a number of different knowledge gaps and needs that I think can be relatable to the atmospheric scientists in the audience here. So we recognize that there's a very high variability of heat exposure and heat conditions in the city. So we need improved thermal environmental data. So this goes beyond just sort of your very high quality weather stations at the airports, which have really good quality, but not such great spatial coverage. And it goes beyond, one of the most commonly used tools for assessing the hotspots in a city is satellite-based land surface temperature data from satellites like Landsat 8 and 9, but they have limited utility for a number of reasons. First of all, Landsat has an overpass frequency of every 16 days. That overpass is around 10:30 or 11 in the morning in Phoenix, so it's just a snapshot of surface temperatures. Those surface temperatures sometimes are on 20-story buildings. It's the rooftop they're measuring. And they're not always that well correlated with air temperatures. And so this is some of our recent research with our field measurements with the Southwest IFL is we're actually identifying that the correlation between air temperature variability and land surface temperature variability is not what we thought it was. It's actually much weaker in many parts of the city. So we need better data. And that includes, a lot of the work that we're doing is really trying to understand the neighborhood scale variability in temperatures and also sort of the downwind effects of any of our cooling interventions. And we've done measurements throughout the city, and this is just a snapshot on the right here showing air temperature measurements from car-based traverses. And what we see is on scales as small as 100 or 200 meters, we're seeing 2-3 degrees C difference in air temperatures. And likewise, we've done some experiments where we've put multiple weather stations in a single parcel of land, and we see variations of air temperature on the order of 1.5 degrees C that vary over the course of the day, depending upon the siting of the instrument on that parcel of land. So very important that we get the data right for model validation, model evaluation. But also we're doing a lot of work now with microscale digital twin models where we're starting to recognize the only way that we can represent the complexity of what's happening in the urban environment is to go to finer and finer scales. But digital twins, microscale modeling is useless if your input data are not there to really drive the model. And so that would be another call that I have is we need really good input data for surface characteristics. In Phoenix, we have whole parts of the city that get flood irrigated every 2 weeks in the summer, and that's not captured in any models, right? So we need to better understand the various surface characteristics of the city. So that's another knowledge gap, I'd say. And finally, one of the things that I'm really passionate about is the recognition that heat oftentimes doesn't happen alone. When heat interacts with other aspects of our environment is when we have some of the most dreadful consequences. So for example, heat is associated with an increased risk of our grid failures, right? So we're overloading our utility system, our transmission lines, they're sagging in the heat, they're hitting power lines, there's increased probability of wildfires during these extreme heat and drought events. And so what happens when you combine some of these events simultaneously? Normally we go into the indoors for shelter in Phoenix. So obviously, the unhoused population is a huge, important population. But for those who are housed, I think Dave Hondula can probably correct me if I'm wrong, but for the vast majority of the cases of heat deaths inside, those homes had air conditioning. They just didn't have working air conditioning, right? So because of a lack of access to economic resources, people either don't run their air conditioners, they don't put the AC down as low as they really need to survive, or maybe the Freon has been leaking for the last 10 years and it's blowing hot air. They just can't afford to replace it, repair it, and so forth. And so these sorts of events, when you have power outages, the AC goes out, that's a dramatic impact where the buildings become ovens, especially if you have limited ability to open windows. And that can happen in a wildfire event where you've got, let's say you live up in Flagstaff where most people don't have air conditioning, but they do have extreme heat days periodically. And if you simultaneously have a nearby wildfire, you have to choose between indoor thermal comfort or good air quality. And so I just want to sort of conclude with one story that I think exemplifies one of the frustrations that I've had as a researcher. And so it's really the challenge of communication of nuanced or complicated findings. So I'm going to do this in the context of cool paving. So it's an image of cool paving here on the right. It's simply more reflective paving. And the way it works is it reflects more of the sun's energy, so it absorbs less heat. So it reduces surface temperatures, it reduces the stored thermal energy in the pavement, and as a result, it reduces near surface air temperatures. And these effects happen all day long. The stored energy doesn't get released at night like it would. So you actually have time scale of benefits that last hours. Now, on the flip side, if you're a pedestrian walking across that cool paving, well, for the 5 or 10 seconds that you're taking crossing the street, you will experience more reflected shortwave radiation hitting your body. You might feel warmer because of that. And the important thing I want to point out here, though, of course, is that unless you live in the street, and some people do, and we do have to be careful about that, or unless you play on a playground for an hour at a time, which many of our children do, simply walking across the street is a very sort of low exposure event for the vast majority of people. So nevertheless, about 5 years ago, there was a reporter that wanted to do a story on cool paving, and he interviewed a number of researchers, including myself. I told him the whole story. I know he got the whole story from a range of different researchers about some of the benefits, some of the concerns. There's some disbenefits from other perspectives as well, other than thermal. And he wrote a story, but ultimately he has to pick an angle for his story. He picks a headline, and that headline is, "The problem with cool pavements, they make people hot." Literally within a week, you could go to some of the industry online blogs and services, and they actually accentuated that title and not only said they make people feel hot, which they can with respect to reflected radiation, but they actually claimed, oh, they actually make the surrounding air warmer. About the same time, there was a city in Southern California that was considering a project where they were going to do cool paving in their city. In fact, it had been approved. And within weeks of this first story coming out, that city canceled their cool paving project. Now, I cannot tie this in terms of a causal relationship that, yes, the story caused this decision, but just think of it as sort of a cautionary tale of how important it is and how a rogue title that misrepresents the totality and the complexity of the story can actually impact decisions that are made by city managers and others. So I'm just going to conclude with just sort of 3 comments of where I think my research with the Southwest IFL is suggesting there might be some needs or opportunities for the scientific community to help. So first of all, I'd say at the micro scale, we need better data for microscale modeling. We need better information about surface characteristics, not just where the buildings are and what size they are, but we need actually building materials, paving materials. We need to know more information than probably is easily available. But if we want to do it right, we really need better data. And we also need the modeling to export for us information that's useful about the complete thermal environments. It's not just about the air temperature that someone's exposed to. It's about their thermal environment, the accessibility of shade, whether or not the surfaces surrounding them are hot, and so forth. And then the second item here is just that I think it's important that we start working more across disciplines to better understand some of these interactions and feedbacks across different urban systems. So this idea of what happens when you have a power outage with the wildfire, with extreme heat, and understanding how that impacts the different endpoints that we're interested in. And then finally, we need to be cautious and demanding in our communications when we're trying to communicate complex findings to the media and the public. It's very easy. It's even easy for us as researchers. We focus on one aspect of a problem. We tend to sometimes not talk about the things we're not as expert in, but recognizing that we need to share the pros and the cons and really try at least to tell the whole story is important. So I'll leave it at that.
Thank you, Dave. That's very helpful. And rounding out this group, well, another reminder to put your questions into Slido because we're going to have those at the end of this. We've got Lisa Patel joining us, and she'll talk more broadly in our application too of not just a Phoenix type heat, but the health impacts, what can be done about that, and what she's learned through her work. And she really has been a trailblazer in this field of climate and health. So take it away, Lisa.
Thank you. And just in the interest of time, I'll keep it a little compressed so we have time for questions. Can y'all hear me?
We've got you.
Oh, great. Okay. So I play two roles, as was mentioned at the beginning. I both lead the Medical Society Consortium on Climate and Health. We bring together 58 major medical societies, understanding that climate change is a profound threat to health and a driver for health inequity. And I'm also a practicing pediatrician for a small community hospital for Stanford Children's Health. And Dave's presentation was a perfect segue to one of the first things I wanted to talk about, which was surface. So I often provide this picture here. This is a man who stepped outside after a run of several hot days in Phoenix, Arizona, and that pavement really held on to that extreme heat. And so he got outside, got dizzy, fell down, and sustained a 2nd to 3rd degree burn just from falling on that pavement. The pavement was holding on to so much heat. As was mentioned, I live in Northern California. I live in San Francisco, an area that is not at all adapted for extreme heat because it's not an area where we've ever encountered it. But I also grew up in Houston, Texas, a place where it is adapted for extreme heat because we have more hot days and more humid days. So I would go from my air-conditioned car to my air-conditioned school, back to my air-conditioned home. That isn't the reality we live with in a place like Northern California. The hospital where I practice is in Livermore, California, where you can see during the heat dome event that we had in 2022, temperatures topped 116 degrees there. I was a hospitalist throughout the pandemic, and I will tell you the 2 days that I spent in the hospital during that extreme heat event rivaled how busy I was during the pandemic. We saw multiple mothers in labor where there was some complication. Often it was being called as chorioamnitis, and what we figured out later that maybe played a role is that many of the laboring rooms were southern facing, and it was so hot outside, it was just, we were unable to cool it inside as a result of it, and that extreme heat probably stressed out the fetus in utero, which led to me needing to go to a lot more deliveries than I would normally go to. During that event, I was also treating more children that were coming in with various asthma exacerbations. We also had an outdoor worker come in with rhabdomyolysis as a result of extreme exertion during periods of extreme heat. And so the issues that we're seeing in Phoenix, we are seeing throughout the country, and these are big problems in places both that are having more hot days that are adapted to it, but also in places that haven't been adapted, and we have to think about what resources make sense in those settings. In terms of what it's like to practice during these events, I really liked this coverage from the Washington Post for the Oregon heat dome that happened in 2021. Physicians raced to provide fluids to patients who arrived breathless, dizzy, and drenched in sweat. Others were brought in on stretchers, their body temperature so high, their central nervous systems had shut down. Those who could still speak told of stifling apartments and sun that made their skin sizzle. Some had tried to walk to county cooling shelters only to collapse in the blistering heat. Now, there are a lot of physiologic studies that look at what are the maximal temperatures and also accounting for a humidity for what the human body can handle. As you can imagine, this is a really difficult question to answer because it depends on what the health or the age of the individual is, in addition to whether they're exerting themselves or not. But some new data that came out last year indicates that our maximum wet bulb temperature, so this accounts for both temperature and the humidity, is about 93 degrees Celsius, something that we are exceeding in most parts of the world. So what happens during a period of extreme heat? And I think this is just important to understand as we understand what interventions work. As the external temperatures increase, our internal temperatures increase as well. And when that happens, our body starts to pump blood to the periphery, and it does that to engage in evaporative cooling, and that's sweating. Basically, it's a gigantic sprinkler system that we have for our body, and that's really the only way physiologically we have to cool down, other than behavioral things that we can do to adapt, like moving to a cooler place or applying things like ice or a cold wrap to our bodies. Now, as your body is starting to pump blood out to the periphery, if it's so hot outside that the blood doesn't cool down, your body doesn't really have another mechanism to address that extreme heat. It'll just keep pumping blood out to the periphery. As that happens, your heart beats faster and faster. So you can imagine somebody who's elderly, for example, can't take that strain, especially as the heat carries on. And then central parts of your body, so your organ systems start receiving less blood. That can result in end organ damage. And if this carries on, it can result in heat stroke and death. It's really important that we have more education available for folks to understand what both heat exhaustion and heat stroke look like. Amber was talking about how athletes, for example, are especially at risk, because what I've found as a pediatrician is that a lot of coaches, for example, and parents really want their kids out there on the field doing the best they can do and tough it through. And as a result, we are missing the opportunity to provide education and keep people safe. So there are more and more government entities, public health departments that are providing this type of education and guidance on what heat exhaustion looks like. And really, you want to catch people during the period of heat exhaustion to prevent what can be fatal heat stroke. And so heat exhaustion is somebody being faint or dizzy, excessive sweating, rapid weak pulse, nausea, vomiting, cool, pale or clammy skin, muscle cramps. And again, once you get to the point where you're having these neurologic symptoms, throbbing headache, being confused, this is an emergency. And it's really, really like calling 911, getting that person emergency care as soon as possible to prevent the worst outcomes in terms of the effects of heat. When we think about heat, and I think this was mentioned across multiple speakers, we really need to bring a vulnerability frame to it, because there are segments of the population that are more vulnerable, and we are going to see those vulnerabilities increase. We are seeing in terms of where federal priorities are, that there is a rule, for example, being considered by OSHA that was introduced during the prior administration to keep outdoor workers safe. We don't expect this administration to take that standard up. And so it'll become increasingly important to think about how we protect outdoor workers on a state-by-state level. Outdoor workers are, especially farm workers, 35 times more likely to die during extreme heat events than the rest of the population. Infants in particular, I've treated a number of infants that have come in severely dehydrated during periods of extreme heat. It has become a standard part of my practice to ask a family that's leaving the nursery, because many of my patients are on public insurance and don't have air conditioning in a place like Northern California, or as was alluded to, can't afford to pay their bills. We are also seeing, in terms of budgetary priorities, a cutting of the LIHEAP program, which has been a lifeline to many of my patients that can't afford to pay their energy bills. If that gets cut, we can expect more individuals that won't be able to turn their air conditioning on. And through my screening, I have actually identified 2 families that would have gone home with their infants in a heat wave in their homes, their apartments, where they didn't have air conditioning. So we worked with social work to find them a safe place to be. And then pregnant individuals are at higher risk for adverse birth outcomes as well. There's great work going on by organizations like March of Dimes and ACOG, but there's a lot more work to do across medical professionals at large, because extreme heat carries risks for things like preterm birth and low birth weight infants. We need to start building in that kind of counseling in our visits with our patients, so they're aware of the risks and can take the appropriate precautions. We've also talked over these 3 talks about how we count deaths. And I just want to take a moment to talk a little bit about that, because Dave Angela had provided the statistic about the number of deaths that were counted in Phoenix, and we did a similar count here in Santa Clara. But as we've alluded to, these counts are actually difficult to get accurately. And they're difficult because the death certificates can often be unreliable, and that is because we are not providing, again, the counseling to health professionals to be considering what the interactions between heat and the morbidities and mortalities that we are seeing in the hospital when they're accounting for this in terms of their documentation. And so what we need from the point of view of health professionals is more education and training, and more what we call ICD-10 codes or billing codes, so that health professionals are providing that documentation, and we can get a better count on the number of deaths that are happening as a result of extreme heat. A final word, just in terms of what role health systems need to be playing in all of this. We put out a paper a few years ago in New England Journal of Medicine Catalyst, and we really looked to examples in places like India that have been dealing with extreme heat for a long time. And what we found there is an integrated public health and health system response that we really need to build out in a better way in this country. And again, this will be difficult to do in the current context when we are seeing huge cuts to public health, when we need more dollars to go to public health to allow for this kind of response. In the meanwhile, health systems need to take a much more active role in working with their county public health departments. And the other roles that hospitals can play, in addition to increased education, we can be using our community benefit dollars to be ensuring that the communities around us are resilient in the face of extreme heat by things like urban greening campaigns. We can be providing resources and education to our patients that we know are more vulnerable during periods of extreme heat, to things like county cooling shelters in the county. And then in New York City, what we learned is that during their extreme heat events, they actually allow their emergency rooms to be used as additional sites of cooling. So this is a concrete role that health systems can play to increase the sites of cooling for patients and for the community. And with that, I will end so that we have some time for questions.
Thank you, Lisa, and everyone. Just so much amazing information in there. I have to say, you answered a lot of questions I had ahead of time, but there are more that are coming in. And one I'd like to get to start, and this is from one of our board members here. Let me just pull this up. This is from Jonathan Patz, and it's for Dave Saylor. A question about depending on humidity, fan first cooling offers large benefits both for cooling and energy savings. And he linked to a publication here that I can share. Wonder if fan first would work in Phoenix, or maybe it's just too low of a humidity for that. So thinking through that concept of balancing fans within the reliance on electricity for air conditioning, where are some of the limitations of that, or where can it be applied?
Sure, thanks. And thanks, Jonathan. Nice seeing you again. Yeah, so the most expensive type of air conditioning is your standard air conditioning unit. And there are many ways to cool yourself, provided it's not a very dry out. Well, actually, it depends. So if you think about in Arizona, we have a lot of swamp coolers, and those work by evaporating water. That works well when it's nice and dry out, but during the more moist monsoon season, they don't work so well. Fans work pretty well unless it's above a certain temperature, and then you're essentially putting yourself in a convection oven, right? Because if the air around you is hotter than your body surface temperature, then it's actually putting heat into your body. The other thing I've seen stories of elderly who've died in their lounge chairs with a big fan in front of them, and it wasn't because of the convection oven effect. It was a dehydration effect because they were evaporating so much water that they dried out and they eventually passed away. So certainly under certain circumstances, fans do really well. I mean, I think the health experts probably have a little bit better view into sort of the body sort of thermodynamics of its response to to fans only. But fans have been used for many years and have been very effective solutions that are really inexpensive. You can throw a wet towel on a fan and get some benefits really inexpensively. But that's, I think, as much as I'm able to comment on it. Yep. Dave?
I'll defer to Lisa first.
Okay.
And then defer to medical experts.
Yeah, there is an upper limit in terms of heat, and I think it's about 90 degrees or so, after which you're just blowing hot air. The way you get around it in lower resource settings is that you can put a bowl of ice to cool that air as it comes out at you. But yeah, it's going to be somewhat limited depending on how hot it is.
Vernon, if I might just piggyback.
Yeah, go for it.
I think one of the functions of the heat office is to be on continual scan mode for the research that's out there. And our colleague Ollie J in Australia and his team and network have been doing some really interesting physiological research challenging some of these urban myths and legends about what the magic temperature is for using a fan or not using its fan. And what we were proud to be able to work on with his team was taking some of their findings that were reported in the Lancet a year or two ago and converting it into some type of, I'll call it semi-public friendly infographic of course, there's still a lot of nuance, still a lot of detail, but at a minimum, converting some of the temperatures into the right units for our American audience and so forth. So we have an infographic that summarizes their research on the phoenix.gov/heat page to try even just the awareness that there are these low and no cost strategies like the ice bowl in front of the fan to keep promoting that messaging. I think that research translation role is a really important one that there's probably tremendous opportunity for more of all across the country.
There were two questions that came up about the heat risk index map. And for those who haven't been following along, it really is a tremendous tool. And it's just to give a little more perspective, the government the past couple of years has done a lot of work to put together heat.gov. Now, the actual name is NIHIS, which is National Integrated Heat Health Information System, NIHIS, and you can find it at heat.gov. But there are some concerns about going forward for obvious reasons. So what is the status of heat risk this summer, the tool itself? Do we know?
Amber, the best information I have is that we're still operational.
Yeah.
I think there have been, I don't know how much is based on perception versus reality, but I've certainly heard concern that heat.gov might be taken down and people working to create archive versions of it and so on. But we have not heard any, we have regular updates from our National Weather Service office to the local heat community here. And there has been not even a whisper of a threat of interruption to the heat risk tool. But that would be very consequential if it were to be interrupted. So we would certainly be happy to amplify any recommendation for that service to continue. As Amber probably knows the best of the group, being able to communicate authoritatively some level of risk outside of the heat warning days is tremendously critical here.
Yeah, and the local National Weather Service office in Phoenix over the last year or two has transitioned to pretty much exclusively using the heat risk tool as their way to determine whether or not they want to issue an excessive heat warning. So they're basing it off of that, as opposed to just some, I guess, value of how far above normal we may be.
Bernadette, while we're talking to heat.gov in the federal landscape, I do think it's important for the board to be aware that heat does not have a national coordination home like other hazards might have. There might, I don't know, but there might be a stormwater management society and conference, or hurricane return, and heat doesn't really have a home. It fits in a little bit to the Urban Sustainability Directors Network, certainly National Adaptation Forum, and it is covered in a lot of settings, but it doesn't really have an owner or home at the national scale. And what we unfortunately saw this year is that one of the early efforts to create such a home, the national meeting organized by our NIHIS colleagues in mid-April, was canceled. So one of the key opportunities for cross-city and cross-partner dialogue at a national scale this year was not able to occur. And I think we need to keep looking for opportunities to create that information exchange. And there are great partners out there who are doing it, but we need to upscale and accelerate.
It's a very good point. So for people who may have opportunities for convenings who do have any connection to heat, this is an opportunity maybe to bring in some amazing partners and build that out. And another thing to build upon that in our prep meetings, I mean, this came up with Amber and Dave, but others might have comments on this too. Lisa, I don't know what you've done with this, but there's no official emergency declaration status on heat either. And so it's treated very differently than other types of extreme weather, where again, it's our easiest to forecast and it's still killing more people than any other. So what would an emergency declaration status really do for you, your preparation, response, all of that? Maybe help people understand why that would be of value.
Last year, so we have an ad hoc coalition of organizations. This includes the Alliance of Nurses for a Healthy Environment, American Public Health Association, American Lung, and a few others. We had come together around two areas where we really wanted to do some work on the policy side. And one was to get FEMA to declare periods of extreme heat as an emergency if FEMA can make those declarations, it brings federal resources and federal coordination to bear on these emergencies, particularly for all of the challenges that we've raised during this conversation. With the shifting political landscape, we have decided that that wasn't going to be a fruitful end for our efforts. And so we're really shifting towards focusing our efforts on outdoor heat workers, because they are one of the most vulnerable. And that's going to be our focus for this year, because we just don't see it as a viable place for our activities, unfortunately. It would be great if we could get it done.
Bernadette, I'll piggyback. Of course, we're watching closely the dialogue here and trying to contribute to it, and also some heat efforts being put forward by members of Arizona's congressional delegation and others. So it is an interesting time politically for heat, and there are people trying to advance initiatives on the idea of an emergency. I think part of my lesson learned in this conversation is that this has been a bit of a two-way street, or the absence of a two-way street. We can certainly pull reports of FEMA disaster declarations and so show there's been essentially zero investment in quote heat disasters, however they might be defined. But there also haven't been many asks from local government up the food chain to the federal government. And I'm not sure that communities all across the country, and I would say Phoenix included, really know how to make that ask right now because of the relative new position we're in trying to formalize our structures. So I think there is a lot of work to do at home to get our plans ready to know what does it mean to exceed local capacity in a heat event, and what is the next thing or 10 things or 100 things that we would need? How much do they cost? How quickly can we get them? I think that work is still desperately needed at the local scale as well as we look at an evolving federal landscape. And one final point on this, we talked so much about health. And I've certainly heard FEMA leadership in the past talk about FEMA as an infrastructure agency. Should we expand the conversation for emergency declaration to also be thinking about the CDC and HHS side of the house, if this is arguably just as much a health emergency as anything else?
To the infrastructure point, we actually have a question here from one of our board members, Kevin Gurney, who many of you also know, another Arizona guy, who will be part of this session tomorrow. And he says the health implications of extreme heat are certainly paramount, but wondering if there is good understanding of what extreme heat costs in terms of infrastructure maintenance, service breakdowns, roads, airport functions, et cetera. So David Saylor, probably starting with you with this one.
Sure, and I don't have numbers for you, but a while back, the Nature Conservancy commissioned a report looking at, it wasn't about extreme heat per se, it was about the cost of inaction with respect to climate change. And I know, they tried to monetize everything in terms of impacts on heat-related morbidity, mortality, hospitalizations, but they also looked at costs of energy, and we've done some of our own work on cost of energy. I'm not entirely sure if they had infrastructure, failures and repairing. That's obviously something very difficult to estimate, I would think. But that might be a starting point. I don't have an answer for you though, and I can look up the report. I've got it on my computer somewhere.
There are also there are cost estimates in terms of loss of worker productivity. There's good increasing evidence about hot days obviously are days of poor learning for kids, and that poor learning accumulates over their lifetime. Amber raised this issue. I've done a lot of work on school preparedness for climate change, and I will tell you, our schools were built for a different century, and they're poorly prepared for the threats that are coming, which will hurt their lifetime of learning, graduation rates, employment prospects. So there are both the concrete effects in terms of damage to infrastructure, and then there's workforce productivity and education that are going to be harmed as well.
And Kevin had another question here also, and he said there was talk about snowbirds, but wondering about the exodus during heat. Does that have regional, economic, or other implications? And I'm going to expand this a little bit because I know, having known Amber personally myself and being out in Arizona during heat events, she was explaining in a story of how so many people who are not used to a certain type of heat, they go somewhere, they think they can handle it. And heat is one of those things, obviously, that breaks you down. So you're not thinking clearly. And as you're on a trail and you're not thinking clearly, that there are so many rescues they have to do that her station is covering all the time. So I think the snowbird, not just the concept of when there's an exodus, but taking people who aren't used to a particular situation and putting them in that and what that means and what education's around that. I mean, I'll just say one more thing. I know we talk about that a lot with hurricanes in Florida with people moving there, but there are so many people moving to Arizona. So how are we thinking about snowbirds and the implications on things?
Yeah, I think it's two different things. So the snowbird issue is they're out of here during the hottest months of the year. So there's an economic impact, especially in areas where they're highly populating parts of the valley. Say, for example, Sun Lakes, Sun City, parts of East Mesa. These are very heavily populated with snowbirds. And so there is a local economic impact for the months that they're not here. And then the other part of that is visitors to Arizona. And this is not just during the summer months, but this is in months that would maybe not be considered our heat risk months per se, but for visitors that are not used to even what I would consider moderate heat here in the valley, it's extreme for them. And we do have a lot of rescues off of our hiking trails for hikers that can't take the heat and collapse. Over the last, I would say probably decade, there has been a push to install signage and other kind of warnings at trailheads. The city of Phoenix now closes certain trailheads that are the most popular to tourists when there are extreme heat days. At this point, I think that's tied to the excessive heat warnings, which will now be labeled extreme heat warnings moving forward. But again, you could argue for people that are not acclimated to our heat, there is still an incredible danger to folks out on our hiking trails, even without those warnings in place. So we do have to kind of step up the messaging, and I don't know exactly what that's going to take, but right now, you go to the hiking trails all across the valley, there is signage there saying, be careful. Heat deaths can happen at any point of the year. Make sure you have these 3 things. Make sure you turn back when your water is half gone. There's tips out there, but I think there's always more that we could do on that front. Maybe education from the second they land at Sky Harbor or at the hotels or resorts that they're staying at before they head out. Maybe it's the front desk at the hotel saying, here's your amenities, here's your room key, and here's the tips you need to know about surviving here in Arizona. So, something to that effect. I'm sure others have ideas, but it is a big issue, and it's a year-round issue for visitors. I would say really the only time of year it's not a problem is perhaps December and January, but the heat's starting sooner and it's ending later in the year, so it is becoming a nearly year-round thing that we need to address now.
And I think piggybacking on that, on the snowbird question, I think was it Kevin? I've been very interested in this myself because I'm interested in the dynamics of population movements, and I know there are something like 100,000 Canadian sort of long-term residential visitors or whatever per each year, and probably another 100,000 from elsewhere, Alaska and the Northeast and so forth. So, it's a non-trivial number of people coming to our state to take advantage of the cool weather. And so if they shorten their visits by 10%, you can imagine there's sort of that 10% economic impact. I'm also interested, though, in wondering, I experienced this firsthand when my wife and I moved here 9 years ago. We actually openly asked ourselves, should we be buying a house? And, should we be investing in real estate in the state? And, same thing from business leaders. Are they going to continue to expand? Are workers going to continue to want to come here? And I think that's something that we really need to get a grip on, because, a few major headline stories, Phoenix has a 2-day power outage during June. Just imagine the headlines when that happens. So we need to really make sure we get a handle on how to manage this now, because it's potentially a very substantial impact on the city, on the economics of the state.
Yeah, and just to add to this, there's something called the survivability threshold, which again is hotly debated what those thresholds are. But there are places in Southwest United States, the Middle East, parts of South Asia that are expected to exceed that threshold in this century, maybe the middle of the century at the rate we're going, because there's a point at which we really cannot adapt our way out of that extreme heat unless you just want to stay inside all the time and you have access to air conditioning all that time. We are already seeing 3 million people within this country listed climate change as the reason why they've already moved internally. We expect another 11 million to move from the crumbling coastlines. I was at a White House event under the prior administration where I was a part of a migration work group, and that we don't have good plans in place across as these big population shifts start to happen, and what it's going to mean for each place as places just they're not viable. They don't have, it's too hot. There's not enough water. Wildfires, like all of these issues are huge issues that we don't have good plans in place for.
I'll just add one more thing too, because Arizona was founded as a state on what we call the 5 C's, which have fueled our economy since the early 1900s. And it's climate, cotton, citrus, copper, and cattle. And as our climate changes, that 1 C is affecting all the other C's that have historically driven our Arizona economy. So, there's major implications for a changing climate economically here in Arizona.
That survivability factor, Lisa, we at Climate Central, for anyone who wants to explore this, had done one of our weekly Climate Matters on shifting cities. What we did is we took an average summer temperature for a few hundred cities around the US, projected it out to the end of the century, and did a correlation of where that is now. And so for a lot of the Southwest, we had to take it to the Middle East. And then when we were looking at Middle East cities, there was no correlation. There was, none existed. And so that's what she's talking about, that these are in our climate models now at certain levels. So this is one of those things that really needs to be taken seriously. Another question that we had here too, that this could be a positive one, but it was Dave, do you think that the cold immersion treatment and the overnight shelters helped lower the death toll in 2024, noting that it wasn't quite as high as year before? Have you been able to do any attribution on that?
Yeah, thanks for the question. It's certainly our hunch and our intuition that those are the case, and we have anecdotal evidence that would link in individual circumstances to avoided illness or deaths, but a comprehensive evaluation, an attribution study has not been done. And I think there's a lot of complexity and nuance to executing such a study. I'm not even sure if it can be done retrospectively or cross-sectionally. I think we might need to think about some prospective longitudinal cohort type studies in this regard. We were actually checked in a meeting by our city manager because we were saying how proud we were of all the things that happened, and it appears that might have contributed to this. And he said, well, don't forget, we also had the first major naloxone distribution program in the city last year. We had more shelter beds open than ever before last year. We had more housing placements than ever before last year. So there's this full basket and portfolio of strategies that impact our heat outcomes, some of which are very heat related, like cold water immersion, some of which feel at the surface very not heat related. And they all have an important contributing factor here. So I think we need teams of experts like the coalition gathered here today to think about how we learn to communicate the benefits of these types of investments as we look for different funding and investment sources, whether it's our own taxpayers, federal philanthropy, and so on. I think there's much more of the story still to be written here.
So this one could go to any one of you, really. And I know that Amber, especially based on your last comment, but that you go deep with your Arizona culture and knowledge. So the question is Indigenous knowledge included in solutions pursued for climate and extreme heat resilience? What are some novel, creative, effective methods of mitigating heat and boosting vegetation, creating shade that others can learn from? Now, knowing that our heat is changing from what it used to be, but still what could be learned or applied?
I think I want to bounce this to David because really the only concrete plan we have is coming from the city of Phoenix, right, David, at this point?
Yeah, I think I think we have a lot of work to do to think about the built environment, as Dave Sarah alluded to, and he'll probably be eager to jump in next. The construction of our building, the material of our buildings, orientation materials, and certainly the landscape. And I'll give maybe a little bit of an over dramatized example for the sake of conversation, but I remember back in grad school, I took a climate and architecture class, and I believe I learned that the ideal building type for the desert is somewhat of a low profile earthen building that has very few windows. And the image that you see behind Dave Saylor, not to speak ill of our dear home university, but the image you see behind them is the building that we are in at ASU, where the Urban Climate Research Center is housed. And as you can see, it is essentially the opposite of a low profile earthen building with very few windows. It is a 6-story full glass cube. So, and it has a certain aesthetic appeal and charm and so, but it's just an example that we have tremendous opportunity to think about the design of the built environment in a way that harmonizes some of the practices that people who were here hundreds of years earlier or longer knew and integrated to daily life. Dave Saylor, I don't know if you wanted to add any more on that. And of course, not speaking ill about our dear home here on Tempe campus.
Yeah, no, I wasn't even thinking about what was behind my head as the question was asked. No, so I mean, there are designs. I mean, going back, centuries to like what's been done in the Middle East in terms of like wind catchers, architectural designs that take advantage of channeling of winds and use of water. I seem to recall that, I'm not sure if it was the city of Phoenix that was doing this, but down by what used to be the zone, in some of the facilities areas for the unhoused populations, I thought they were going to put in a wind catcher, or it was like a natural cooling tower. Yeah, so an outdoor cooling tower. And so there are things like that. And this is not indigenous knowledge per se, but like the wind catcher generally is. And so I think there are things that we can learn from architecture going back through the centuries. But yeah, that would be the closest example that I can think of what Phoenix is doing that might resemble some sort of very ancient approach.
Yeah, Bernadette, I think those conversations need to be had at like a statewide level. I mean, David, you can correct me if I'm wrong, but I think most of the work that we've done on this has been through the city of Phoenix, and to a much lesser extent elsewhere across the state. And just anecdotally, back in the day, 1970s, 1980s, there were a lot of houses that were, as Dave Hondula mentioned, they were 1-story, very few windows. That's the kind of house that I grew up in. But those older neighborhoods are consistently being torn down and revitalized and turned into bigger, different style architecture houses that is not necessarily Arizona looking.
Can I just add the perspective of like other parts of the country? And as we think about outdoor infrastructure as well, I was just a part of a collaborative as we're thinking about outdoor learning spaces for children and moving away from these plastic playgrounds. What we're seeing in California in very hot places that they're just putting these plastic tents on top for cooling. And as we reimagine our spaces, there's an opportunity to build upon indigenous knowledge, to bring back native species. We know for 1,000 reasons that green spaces are so much better for us from any angle you look at in terms of our physical, emotional, mental health, social cohesion. So how can we build more nature-based infrastructure and move away from some of the other structures that we've built that we think are better for children, for example, but are actually not, and nor are they good in terms of climate change.
Yeah, and the native species thing is going to be huge moving forward because our heat problems that we're discussing today are closely tied with our water problems. And we're going to need to rely on native species and indigenous knowledge in the water area as well, because as our climate gets hotter, we're losing more of the flow from the Colorado River. And those things are very closely linked. So I don't think we can discuss one without discussing the other here in Arizona.
Bernadette, if I might just piggyback one more on this question. I know we're short on time, but I think Lisa's point is so important, and thinking about maybe a call to action for the audience and the board on this idea that heat needs to be and can be part of every safety conversation that's out there. It's not a guarantee. It's not a sure thing. Amber highlighted the example with schools and now playgrounds. Of course, playground designers and the people who write playground safety standards do think about safety a lot. You can only fall so far, and the surface has to be able to absorb such an impact. Well, at least in our area, a lot of the surfaces that are safe to absorb that impact are rubberized, which is one of the hottest possible surfaces to be on. It introduces burn risk, but the safety guidelines don't think about heat yet as formally as they could. What does the Safe Routes to Schools program mean? What does Vision Zero mean in road safety? All of these concepts can integrate heat, and we are just at the early stages of really connecting those important concepts. So thanks, Lisa, for the example. I think it's a beautiful exemplar.
And Dave, to expand, it's one small part of it, but in that safety conversation, I know in our AMS circles at the broadcast conference, there has been a real push to safety in cars for too many. Any is too many, right? Deaths of kids in cars because how the temperature just spikes so high at even a lower level outside. So really targeting what you're saying there too, of incorporating it into so many all safety pieces. I have one more question here that looks a little forward thinking too. It's not really indigenous nature, but it's how we use the power of our sun. One thing that's a plenty in Arizona is the sun. And from my understanding, which is limited, that the use of solar energy has also been on the rise, but still slow to evolve. And one of you, I'm not sure who would be best at this, whether it's one of the Daves or whoever, what the status is in advancing solar energy to supply the needed electricity that's growing.
I'll jump in on that to start with. So, yeah, we have a lot of available sunlight here in Arizona, and used right, it's absolutely the way to go. One just caveat from an urban climate perspective is that with today's current efficiencies of PV panels, so 22%, whatever you can get in the market right now, those panel surfaces actually warm the air during the day. And so they do, if they're used to provide shading, that helps in terms of the thermal environment. But overall, they can actually warm the temperatures of the air. So thinking about where you place these carefully, so that you're not unnecessarily adding heat into your neighborhoods. So having them further off the ground, for example, really high up, is probably not so bad.
And so there is one last one here because we are almost out of time. We have 3 minutes. It's been such a fun session. Thank you all. I mean, a terrible topic, but a great set of guests. This one was from Jonathan Patz also, and his question is for you, Dave Saylor, regarding green space. Assume consideration of tree species. So pick trees that don't release too much isoprenes, ozone precursors, as well as aeroallergens. So in that built space and green spaces, how much of that's being considered right now?
I mean, I think there is, like, you want to stay away from eucalyptus, right, for isoprene and monoterpene emissions. But I think there is, this recognition that we need to stay with drought tolerant native species for the most part. One of the things that we have to keep in mind is, and this is a challenge for the city, is, you want to plant a lot of trees to provide cooling corridors. If they're drought tolerant trees, they're likely very slow growing trees. And they also transpire very little moisture. So they provide shade when they're at maturity, but they're not going to provide much in the way of benefits until you get them to maturity. So that's where we have to really be forward thinking and say, in 10 years, we want this to be a shade corridor, not it's going to be a shade corridor tomorrow, unless you do that with artificial, shade structures, which you can do some combination. But yeah, you have to be thinking about how these trees impact not just air quality in terms of emissions. There are plenty of low emission species, of course, but you have to think about how the root systems interact with subsurface, infrastructure, or the branches, interact with, overhead power lines and so forth. So there's a lot that has to go into your thinking about that design. But you can pick plenty of tree species that are sort of moderate growing, moderate water use, native, or at least, appropriate for the climate, that will grow to be 10, 12 feet, and pretty much that's it. And they'll provide a nice shadow for your paths.
Can I just add one more element to this that blew my mind that I learned last week, which is the species of plants that are around us affect the microbiome that's within us. And so as we're thinking about, and there's all this research going on about what it means for immune-mediated disease, autoimmune disease. And so it's a very fascinating connection as we think about returning to those native species and what actually belongs in these ecosystems and how it interplays with our own bodies and our health.
Wow, that is interesting. I don't know if everyone online heard that, but one of the phones was playing an interesting song. So with that, we are at time. I want to send a huge thank you to our panel, and also let everyone out there who's watching know that this will be recorded. You can share this with your colleagues, anyone who could benefit from this knowledge or be exposed to their work so that they could learn and apply it to their work also. So all of that is going to be shared in due time. At this point, though, to wrap up the day, I'm going to hand it back over to Brad.
Super. Thank you, Bernadette, and thank you to the presenters in last session. Let's give everyone a round of applause for an excellent afternoon. Yeah, fascinating session. Both events. I think I think we chose wisely to focus on extreme events. I think there's a lot of really rich content here. In the areas that we were looking for, really, gaps in knowledge, fundamental knowledge. I think we saw a number of good examples there from the speakers. Challenges in transitioning, understanding to operations, and then during the event itself, the challenges and risk associated with that. A few attention grabbers for me. One, the sobering fact about the increasing risk of a changing climate. It couldn't be more obvious in what's going on and how it's impacting the fire and the heat. Very sobering. That's, and also something that we want to continue, as one of the speakers said, want to continue that fight, but that's not a tactical approach. That's the long-term strategic, don't lose sight of that end goal. But it puts us in a situation where we have to address it through other means. We had sort of the all of above discussion idea that, can't really just do one thing. We have to do it all, but we do have prioritization. And how do we look at this, and what are our thoughts on how do we prioritize? What is the sort of the best bang for the buck? And having been one who spent a lot of my career in improving weather forecasting and weather prediction, it's not that. We didn't hear that today. It doesn't mean that we're not going to continue to invest in weather forecasting. Weather forecasting can get better. We can get smaller scale. We can push that forecast skill out in farther ranges, but that's not what we heard today. We really heard that to me, it really brings the spotlight on human and societal actions and responses. It seems that that's where we really need to focus. And I'll go back to Roy's recipe for a conflagration: humans, drought, and wind. So the things that we can really do anything about, humans, right? Drought and wind, we know which way it's going. A lot of research in that. But how do we address that? What do we do with the humans? And it just the contrast between the two, it really seemed to me that, and this was reflected a little bit in one of the questions I asked, we need to avoid conflagrations rather than deal with the conflagration. If whatever we can do to avoid that, you could see that the response in LA is many resources that they had and the ability to put 120 fire trucks out there ahead of time and hundreds of personnel on the ground. In the end, they lost a whole community. And what you can do, and it really gets down to these infrastructure ideas. How can we change and how can we improve things, put in higher fire resilience to try to really deal with that human element of that recipe so that we can try to eliminate rather than just fight. I think that changes a little bit when we look at heat. And that was pretty clear in the discussions here. There's a lot that we can still do during the event itself. But it really does still come down to humans and what humans can do. And we can't lose sight of that. That's front and center. And, you know, urban morphology, that was a new term I had, is, you know, how do we deal with that? All the way to the migration issues came up a few times. And it really does come down to adaptation, mitigation, behavioral sciences, and addressing cultural and economic barriers. It seems that that's where the core value for investment would be, is really how do we, if we're really targeting protection of life and property, how do we save lives? How do we protect property? It really seems to be in that. And it's a fascinating area and two fascinating stories today. And a lot to think about tonight. We come back tomorrow, we get to look at Helene floods, a lot to learn there as well. And it's just, yeah, I think that we hit a gold mine. Excellent job by all the speakers. A thank you again to the people who organized it, put the thought into how to structure this really beneficial. So I think that that's really all I had to say. It was just a great afternoon, and everyone, you know, catch up on your sleep tonight and come back for another great event. We start at 9 a.m. right? 9 a.m. tomorrow morning for the last couple sessions. Casey, do you have anything more you want to add? No, we're good. Okay, we're good. Thank you. And thank you to all the participants from outside who joined our open session.